like TV from other dimensions has a somewhat looser feel to it.
Yeah, it's got an almost improvisational tone.
Hey everybody, I need to update that Rick and Morty one. We should do some more fun with it. I'll probably have time this weekend and everything, so it's been busy with the test. So I like Jordan right there, so I'm ready for the intro video. We got the intro video up. I've got my Legend of Zelda glass. Jonathan, good to see you. And I always ask, can everyone hear and see me? It looks like you can. I like that Tion right there. You like it? Is there an echo? Are you? Pickle Rick. It looks like we're good. Does everyone... He needs a part in it. We could do a Pickle Rick one. If you guys come up with some funny ideas, or if anyone makes some good intros, we could use it. So you might have two tabs open. Tracy, check to see if you have two tabs open. You might have a second tab open with me. Can we also get confirmation? No echo. I'm going to look at my audio sources real quick. I only see the one audio source. Okay, looks good. No echo. Okay, we look to be good. Double check, Tracy. You might have two tabs open. I've done it before. I was on a stream. I was like, "There's an echo," and they're like, "I don't this time." Oh no, I don't know why there's an echo. We have no echo being confirmed right here. Yeah, go out and come back in. Awesome. Okay. So the test is up and going. I looked and it looks like I have a lot of emails. If you notice, if you email me, I've been emailing you back right away. So please email me whenever there's a problem, anything going on. Sorry, there's been confusion on the calculator front. I got confirmation this morning that other teachers are telling people to use calculators. Put it this way, for those who have taken the test, I don't think having your own personal calculator will have, and exam chat for 14 and 15 will be on exam 3. I don't think having your own personal calculator will be any sort of super help for the test. I don't think it'll change any grades. You're welcome, Luke. Yeah, I want you guys to know I am there. So, and if I ever don't respond, it's usually because especially during the day right now, I can't respond to emails really well. So, because I teach from 12 to 5, and when I'm on campus, I'll be on campus sometimes from 9 to 7, and I'll come back and I'll do responses then to emails. So usually during the day is when I'm a little bit slow, but at night I'm a lot faster. We are good to go. So the test is going pretty well. Grades are looking pretty good on it. So I think we got a lot. Email me, Sam, and I'll send you a video for that. Your grades are, yeah, exactly. I'm really fast on that. We've got a lot of videos to help out. The confidence intervals for the proportions. We've been working a lot of those in recent videos. So if you have a specific one you're working on, and then I have been appearing live. I know we've had Carson and Walker on a lot of the live videos, and we're going to try to do that after class today. So if you're ever stuck on a problem, please ask, and we'll try to do as many of those problems as we can. We might even have time today. I think it was Meredith was asking if we could do a problem, so we're going to try to do that and go through as many things as we can. Remember, this video is recorded, so if I say something quickly, if I'm like, let's talk about the p-value here, and oh, that's the wrong thing I'm on. I'm like, let's talk about the p-value for the hypothesis. Okay, let's go on. I won't do it that quickly, but remember, it is recorded, so you can always slow it down, and you can always, rewind the tape, which I really like about putting these on YouTube. Okay, so let's get started because we've got a lot to cover right now. Now make sure, please take the test. If you haven't taken it already, after class, go take the test, find a quiet room. If there's any problems, please contact us immediately. Yes, I knew it was it. I was like, what's going on? So please contact us immediately if there's any problems. Please. So what are we talking about today? Today is probably one of my favorite topics, and I say that so much. But today is all about hypotheses. So when we do the hypotheses right here, the hypothesis is going to be something we use all the time in statistics. So we have to know what it means, and we have to be able to explain to people what's going on with the hypotheses. So let's think for a moment just about a courtroom trial. Now, I did a really cool thing. I did it last semester. I don't have my green screen this time. But pretend that I'm on trial. So I wonder if, it's not going to look right if I do it. So if Brian was on trial because, let's say, he's accused of going after Albert Einstein. So we're back in time now. I'm going to use a fictional character this semester. So we're going back in time. What would you assume about Brian going into that court case? What would you assume about me going into that court case? If I'm accused of something, what would you start out with? Who knows in the chat for 100,000 points? Let's get those answers rolling right now. Who knows for 100,000 points? I'm going to give everyone who answers correctly 100,000 points. You got to answer correctly. What would you assume about him? There we go. Avery's first person to get it correct. Guilty. Don't assume that about me. So innocent, Rachel's right. Everyone's saying what we start out with right here. We start out with innocent. Even Tion doesn't believe me. Tion's saying I'm guilty right now. So remember, if you're putting the answer right now, you get 100,000 points. This is a follow-along lecture where you write the answers in the chat. I'm innocent, free Brian. I like it right there, Luke. Luke, you are awesome. So we assume, Avery's got my back. So we assume Brian is innocent. Tracy says not plausible. So we assume Brian is innocent until proven guilty. This concept, hashtag free Brian. I like that. Extra 100,000 for Sydney. I think it's the best laugh. So Brian is innocent until proven guilty. Exactly. That is what we start out with in a court of law. And this is the idea of a null hypothesis. This idea right here is the same thing as a null hypothesis. We're going to start talking about what is called the null hypothesis. And think of null. Null means nothing. You're starting at the beginning. A very good place to start. In statistics, we start with the null hypothesis, and it just means you start with no preconceived notions. Now, you might say, well, in some countries, the null hypothesis is that you're guilty. Yes, that is true. That's why it's usually just a jumping off point, but you usually try to do it with as few assumptions as possible. Like if I told you, which do you think people like more, Pepsi or Coke? What would the null hypothesis probably say about Pepsi and Coke and which people like more? Think about this, like it's almost like you know nothing. So what would you say between do people like Pepsi or Coke more? 100,000 points, first person to give the right answer. What would be the null hypothesis related to, do people like Pepsi or Coke more? If you knew nothing, people are saying Coke. I mean, I might agree, but remember, you know nothing. You don't know that people like Coke. You don't know that Coke is better. Whichever came first. They like them the same. Campbell, amazing answer. I don't know. My dad worked for Pepsi, but I agree. It's weird. I'm sorry, Pepsi people. But once again, Campbell, right answer right there. They like them the same. Everyone answering and giving you 100,000. Keep these answers coming. I said I was going to be throwing out big points. I am throwing out big points. Pepsi got that twang. So remember, we're talking about, there's a car honking outside. We're talking about if we have no knowledge between Pepsi and Coke, we'd assume, I guess people like them equally. This is what the null hypothesis does. We got people voting Coke for sure right there. The null hypothesis starts out with really no knowledge. You wouldn't usually start out with saying one is better than the other. So we'd assume that they are the same. So then let's follow both of these examples through. Brian is accused, he's back in time now with Albert Einstein, of accosting Albert Einstein. And Brian was in Tennessee the whole time. Meanwhile, Albert Einstein was in New York. What would you think? Now I can prove it. I can say I was in Tennessee the whole time. I've got these people who back up my story. I've got these people. It's a whole list of people. And there's even, for some reason, we've got cameras back then. And I'm like, I was on the set of this thing. I was doing this thing in Tennessee. I was on this music video. I don't want to make music videos back in like, no, that evidence could come to light. But they're saying it was me specifically. So I want us to think about this. In this instance, I want you to use one of these two words, which is going to be very important right here. Would you reject that Brian is innocent? Or would you not reject that Brian is innocent? What would you do? I can show that I was in Tennessee the whole time. Remember, you started out believing I'm innocent. So would you reject that I'm innocent? You'd fail to reject. Melissa knows the right words right there. Fail to reject is classic wording on it. I like to say not reject. Not reject means the same thing as fail to reject. Fail to reject means I do not reject. Think about this. I fail to do this. I fail to reject. Nice answers. 100,000 points in the chat. We're going crazy with the points for the rest of the semester. Be here live. Get those points. I'm going to try to give everyone as much extra credit as I can. Be here live. Be here interacting. That's how we learn. So think about what you just said. I would not reject. Same thing as saying fail to reject. That Brian is innocent. I would not reject that. It means fail to reject in statistics. I fail to reject that. But now let's say Albert Einstein, smart man, finds out that Brian has a twin. I guess you guys didn't know that. It's Brian with a Y. They spelled his name wrong. So my parents spelled my name correctly. So we got Brian with a Y, twin, who's been in Tennessee the whole time, and he shows evidence of that. And then we've got Brian, who's actually been in New York. Albert Einstein's got photos of me. He's got a whole list of my plans to accost him. He's got all of these things. He's got them all documented. He's got a video of me listing out the plan in the future right here. He's got time travel abilities and stuff. So twin is the off-brand. Luke, 100,000 points. So he's got all of this right here. Now with all of this new evidence, what would you do to your initial hypothesis? What would you do to Brian being innocent if you're in the court of law right here and Albert Einstein's giving you all this stuff? He pulls in Brian's twin. He looks just like me. He's like, I'm Brian with a Y. I was the one in Tennessee the whole time. That Brian was in New York. You're saying it. You all of a sudden be like, now I'm going to reject that Brian is innocent. I'm going to reject it. I'm going to say I have evidence that Brian is not innocent. I reject that Brian is innocent. I have evidence that Brian is guilty. Dayline, Brian, and Brian. Jake, 100,000. I'm going crazy with the points, but I like all your guys' jokes. So we have right here the first instance where we didn't, still free Brian. Thank you very much. We have right here the first instance where we could not reject the null because we didn't have evidence. And then the second instance, we had evidence for the alternative, so we rejected the null. Now, what were you looking for evidence of in this situation? In this example, you were looking for evidence that Brian was guilty or evidence that Brian was innocent. What were you looking for evidence of? Evidence that Brian was guilty or evidence that Brian was innocent? And this is big stuff because this is how we could ask multiple choice questions on the test or true falses, which if you've taken test 2, you know it's going to be a lot of multiple choice, a lot of true false. Lecture is more valuable than ever right now. Evidence that Brian's guilty. Miles gets the first 100,000 points to Miles. We're just giving Miles only the points right there. He was quick and wrote a full sentence. Also, Tion, I didn't see it right there. Tion also. Tion and Miles. So why not everyone? Sure. I like being nice to everyone. So evidence that Brian is guilty. So please tell me, what is the alternative you need evidence for? The alternative, what is the hypothesis you need evidence for? The hypothesis you need evidence for is the alternative. You start out believing the null. You start out believing the null. So with our Pepsi Coke example, we would start out believing that Pepsi and Coke are the same. Then we'd look for evidence maybe that people like Coke more. We could look for that evidence. We could look for evidence that people like Pepsi more. We could look for evidence that people like them differently. And this right here is pretty much 50% of the lecture. You just learned a lot of the theory with that example for this whole lecture. So let's talk in some specifics here. We have right here the null hypothesis. So be careful. Oh, Tracy, big thing. I'm throwing you 100,000 points. We will never we'll never use the bad except word. Yeah, 100,000 points still. We'll never use the except word. What are the only two options with the null hypothesis? I want to see it in the chat. 100,000 points, big points all lecture. What are the only two options for the null hypothesis? You can only do two things for the null. Campbell is right. You can only reject or fail to reject. Those are the only two options. So let's make it clear. Let's see this. Let's write some notes on it. So here's what happens. When you do the null hypothesis, if you reject the null, that means you have evidence for the alternative. So when you reject the null, you have evidence for HA, and HA is the notation for alternative hypothesis. But on the other side of this, if we say do not reject null, so do not reject, all you have to do is write do not, and then you just write reject the null. So you either reject the null or you do not reject. That means fail to reject, but this is why I like using do not, because if you do not reject the null, you do not have evidence for the alternative. So if you reject the null, it's because you have evidence for the alternative. If you do not reject the null, it's because you do not have evidence for the alternative. Think about this. I reject that Brian is innocent because I have evidence he is guilty. I do not reject that Brian is innocent because I do not have evidence that Brian is guilty. Use these examples right here to remember how it works. All we're saying is the null hypothesis from our previous example. That's awesome. So the null hypothesis is innocent 100,000 points right there. Innocent. If I spelled it correctly, let's hope. And the alternative is guilty. So insert those words in there. I reject that Brian is innocent because I have evidence for Brian's guilt. I do not reject that Brian is innocent because I do not have evidence for Brian's guilt. This is what we're doing, and this is what you should know. You can say fail to reject, and you probably should know that fail to reject is do not reject. It just means, like I fail to have evidence for the null, you could say probably, but I like the do not reject. And since this is a lot more true, false, multiple choice, I do want you to know that do not reject is the same thing as fail to reject. Just think about it. I fail to reject this. Like, you either go to class or you do not go to class. You either go to class or you fail to go to class. So it's a different way of saying it. It's just kind of a way we don't usually talk these days, to say I fail to do this. That is not our notes, other class. So we have here the alternative hypothesis denoted by HA, all this good stuff right here. But this notation is very important right here. Let's look at the notation. And we have here the null hypothesis has a population parameter. 1 million point question. I want to see a population parameter in the chat. You can spell it out or you can write out million points first population parameter. Who's got it? Who knows a population parameter for 1 million points? Who knows it? Close. If I'm going to give it to you if no one else says anything in 10 seconds. I don't see it yet. 100,000 points each answer, but I don't see one yet. Not yet. No one's got one. Keep guessing. 100,000 points for the answers, but no answers have gotten it yet. Who's going to get it? No one's gotten it yet. A population parameter. Close. Alexandria and Campbell are getting close. No, I'll give it another 10 seconds. I think I might give it to Lauren. I'm going to give it 5 seconds. You guys are on a bit of a delay, but Lauren, people are getting really close now. I'm going to keep it going. A population parameter. So this is obviously something we all need to learn. So make sure to take notes on it when I give away the answer. So the population is the people we want to collect data on. The parameter of interest is what we want to know about them. The population parameter is like a value and a thing we want to know. And so people are saying, people are saying like, so, but what is no one said it yet. I'm going to give it to Lauren, and also I think Campbell was really first, and they gave a pretty close answer. They said average, which is basically the same thing as mean, but no one has said it yet. So this is something we need to take really big notes on. You ready? Here are the population parameters we will use in this class. We will use mu, and so remember Lauren and I think Campbell got it. So mu and p. Those are the two we'll use in this class. We'll also use mu1 minus mu2. It's still mu, but it's still this. So what do we want to understand in example number 1? In example number 1, the thing we want to understand is the what. So now people are saying, yeah, take these notes. These are big notes. A lot of people need these notes right here. In example 1, we want to understand the what. Tell me, what do I want to understand about the population? I want to understand the what for the population. 1 million points first person. Like these random 1 million points. I'll call out your name. The mean, Alexandria, you are right. So Alexandria got it. Everyone else gets 100,000. Alexandria, you are right. In example 2, 1 million points again. What do we want to understand for number 2? In example number 2, the thing we want to understand is the what about the population. In example 2, the thing we want to understand is the what. Yes, Walker, the true proportion. Walker even wrote the full thing out right there. Walker, great job. Mary, you're getting 100,000 for the second answers. For all the remaining, Walker, great job, got the million. Last but not least, 2 million point question. What do we want to understand for number 3? Who's got number 3 right here? Who's got number 3? Keep these answers coming. For example 3, what do we want to understand for example 3? What do we want to understand for example 3? Remember, example 1 was the mean, and that's a subscript right there. So what do we want to understand? Difference in means. Rachel, amazing job. Man, those answers are coming in really quickly. You're right. That is the difference between two means. We want to understand the difference between two means. That's what we want to understand. The population parameter is what we want to understand. Amazing answers. 100,000 points for all these second answers. Thank you everyone so much. I feel that I saw like answers appear so quickly. Great job following along. We want to understand, for example, 3, the difference between the means. So the last part right here, and this is a major important lecture, so be very listening up and know these notations. The last thing over here is whatever we hypothesize the value to be. So we can come up with any value we want. We can just make up a value. So what I'm going to do is I'm going to screenshot this, and we're going to use this to kind of write our own nulls out right here. This is so huge. This is big practice. But we're going to write out our own null hypotheses on a Word document using this as a guideline. So I'm going to give you a question right here, and I want you to tell me the null hypothesis. So here's what we do. Anytime we write a null, it's going to be more multiple choice, but we'd usually do this on the test. We'd write out null hypothesis like that. You always write that. That's always how you start. Now we're going to test to see if the proportion of students at UT is equal to 50%. So we're going to test to see, oh wait, the proportion of males at UT is equal to 50%. But we're going to see if the proportion of males at UT is 50%. So who has an idea of what we would put for population parameter? The proportion of males at UT is equal to 50%. What would we put for population parameter? 100,000 points. Is Brian in the screen super? Make sure to click the scroll wheel and you can increase the quality down low. There's a button that says like increase the thing and you can increase the quality of it. Great question, Luke. 100,000, Luke. So click that scroll wheel and you can change it up to a higher quality. But wait, close. I don't see the right answer yet. We want to test to see if the proportion of males at UT is equal to 50%. So what is the first thing I'm going to put in position 1? There are 3 positions to this. Let's put like a little thing right here. There's position 1, position 2, position 3. So the position 1, oh, nice job, Campbell. Campbell's got it right there. So 100,000 points, all these answers. Keep them coming. So, but I'm lost when you say null. Null just means the initial hypothesis. It's that little O right there. So the null, don't worry, you don't have to like interpret it much. It just means our starting thing, Tion, great answer. And you guys are putting in the chat, guys and gals, we have here that P, because we're predicting the proportion, is equal to, and then we put here 0.50. What if we wanted to see if the proportion of students who like Taco Bell is greater than 70%? Now watch out, I'm doing a trick here. What will we put for the first thing if we want to see the proportion of students who like Taco Bell is greater than 70%? This is a tricky question. I'm trying to trick you. Look at your notes. I tricked you, but you still get the points. So it's P because it's proportion, and then the null always has the equal sign. Cincinnati State Statistics. Oh, that's awesome. Good to see you checking this out right here. Good to see you in the chat. So you got stats in your name. We're making you a mod. We like making people mods here, if you can't tell by all the things. So if you notice, the first thing we need to identify here, we're going to switch up the problem a little bit, is we're going to figure out, are we using the true proportion? Are we using the true mean, or are we going to do the difference? Now, these are later chapters to come. So good to see you in the chat. And feel free. We're just trying to help people out and put stats videos out there and teach students. So what do we have now? Let's see if the average age of a UT student is equal to 20 years old. Now, you're going to have to spell this out unless you have extra things. Why is it 0.7? Oh, yes. This problem right here, the hypothesized value, let's go back to that for a second. The hypothesized value can be any value you want, unless I might have said 0.75. If I did, I misspoke. But you can make up any value. Let's see if the proportion of students who like Taco Bell is equal to 60%. Well, then you can just make that your hypothesized value. So what is the hypothesized value up top? It's any value you want to test. Any value you want to test can be there. Now we have to remember the null always has the equal sign. So don't be tricked when I say things like greater than, because we'll be teaching null has the equal sign. You know it. Null has the equal sign. We always use the equal sign for the null. We'll be doing the alternative in 1 second here, and that's when we start to use the other signs. So since the null has the equal sign, we can do a lot of these problems by this way. let's just leave for the null the equal sign for practice. We're not going to change up what the sign is because the null has the equal sign. So get ready to put in the chat, 1,000,000 points first person to answer it. Let's test to see if the average age of a UT student is equal to 20 years old. Now I've switched the problem a little bit where we're trying to see if the true mean age of UT students is 20 years old. So let's see if the true mean age of UT students is 20 years old. There we go, Campbell. Nice answer in the chat. You got it. We're going to see if mu, spelled out MU right there, great answer, is equal to 20. Now, great. I know a lot of people, this is the trick. This is the small change right here. You have to first ask, what are we testing? We're testing the population parameter, which is the true mean age of UT students. So this is where, hopefully, we don't trick you too much on the test, but you have to say, what are we testing? This time, it was the true mean age of UT students. In the last example, it was the proportion of students who like Taco Bell. Does everyone hear the change in wording? The proportion of students who like Taco Bell, or the true proportion technically, and the true mean age of UT students. Tion, great answer right there, 100,000 points, Tion. Testing the mean age, so you use mu instead of P Alexandria. Great comments in the chat right there. So listen to the very start of it to see what the population parameter is. To see what the population parameter is, we have to clue in on the very start of it, and let's listen in. Here's a super tricky one. We want to see who did better on the test. We're going to take UT students in Florida. We're always, there we go, Cincinnati Statistics. Great answers in the chat. 100,000 points for Cincinnati Statistics right there. We have here, we want to look at Florida students' test scores and UT students' test scores and try to figure out the true difference between their test scores. Now, this is a super tricky one. If you get this example, you've learned this concept really well. So we're going to look at UT students' test scores and Florida students' test scores, and we're going to look to see if there is a difference. So the last answer was mu equals 20. That was the last answer right there. Caitlin, great question. 100,000 points, Caitlin. And they're already cluing in on it. I'm throwing 1,000,000 right there to Caitlin. Ask the question and starting to figure out this one. mu1 versus minus mu2, which is just the difference. And Miles is the first person to give the full answer right there. Miles gets 1,000,000 points. We're just giving out crazy points. I said I would do it. My daughter's a Tracy, that's awesome. It's all good. It's all in fun. I hope everyone knows we're just having fun with these examples. And so we got the Zelda glass, so we're having a great time. But everyone noticed to the question itself, we want to see if there is a true difference between the mean of UT students versus the mean of Florida students. And I didn't give you a value to test, so Miles did an amazing job on cluing in, what is the difference I would assume according to the null? The difference I would assume, if I don't know anything, is I'll assume there's no difference. And technically, what's really interesting about this one is if you do it mathematically, you can write it this way. You would get this. And you could also use a subscript like this. And what are we saying with this way of writing it? Just doing a little algebra on it. We're saying that the score for UT students is equal to the score for Florida students. So it doesn't follow the same pattern if you do it this way. That was just a little algebra to make it say the mean score for UT students is equal to the mean score for Florida students. This is the null hypothesis, and it's how we write it in this class. So let's continue on to the alternative. We got to know about that alternative hypothesis here. So what's going on? This is the notes we were talking about. The population parameter is things like is mu, is p, and then also we're going to use mu1 minus mu2 in this class. Those are the three examples we have. And how do we test this value? We will test it with sample statistics like this right here. If you notice, I'm writing the same version of these in sample statistics. Here, I'll answer the question here in 2 seconds. These are the sample statistics we will use. I wrote the two right here. Are the two means equal to each other? That is what we hypothesize. Great question, Campbell. That is where we hypothesize it. These notes can be found under the modules section. If you can't find it, email me and I'll make sure you have it. These are under the modules on Canvas. So these are the modules on Canvas. So great, Tracy. Thank you so much. 100,000 points, both Caitlin, Tracy, and Campbell. So the null hypothesis we have previously is just kind of an assumption. We're not saying, like in our court case, we're not saying we know Brian is innocent. We are saying we're starting out with the assumption Brian is innocent. Does that make sense? We're not saying Brian is innocent. We're saying let's start out with the assumption Brian is innocent and then see if there is evidence that he is guilty. So in these previous examples right here, what are we doing? We're saying, let's start out with the assumption that the proportion of students who like Taco Bell is 70%. Let's just start out with that. We're not saying that is true. We're just saying this is our starting point with what we currently believe. We're just, it's like, let's see if there's evidence against this. And we're right about to see how we find that evidence with the alternative hypothesis. Here we go. The alternative hypothesis has 3 directions. You can go less than, or this is the less than this today, less than, greater than, or not equals to, which goes both ways. The alternative hypothesis is just like the null hypothesis. Does everyone see how much time we spent on the null? And I want you to tell me 1 million points again. We've got buttons for this Cincinnati Statistics. If you're still here, this is what we usually do when we give the 1 million. I want people to tell me for 1 million points, what's the only thing that changes between the null and the alternative? The only thing that changes between the null and the alternative is the what? What is the only thing that changes between the null and the alternative? Anyone have any ideas? Sign in the middle, Alexandria, you caught on to it right there. Amazing work. So all that time we just spent practicing how to write the null, we now know how to do the alternative. We now know how to do the alternative. By practicing how to do the null, if you get all of your nulls down, at least with this type of notation, your alternatives are like that. If you're doing these types of statistical tests, you write the null, you know your alternative as long as you can interpret it. So let's go back to some of those examples I talked about. You guys know I love Taco Bell. Once all this stuff ends, I'm just going to go to Taco Bell endlessly. Probably. It'll be sad. So we're going to write the alternative hypothesis right here. I will say this, some other classes sometimes use a 1 right here. I just like the A because it stands for alternative, but I have seen that notation. I like the A. It's my personal preference. So we have here the alternative. And what do we have going on right here? We have position 1, position 2, position 3. This is so key right here that when we do position 1, it's just going to be this. Same thing. When we do position 3, it's just going to be this. How do you know the middle part? The middle part is only going to be a change in signs. And I should ask Cincinnati Statistics, are you Matt Bogner, or do you know Matt Bogner? I think he works at Cincinnati, or maybe he's Ohio. He might be Ohio. But he makes really great applets. So I don't know if you know him. So the way we do it, and so you will have more or less or greater than or not equal. You'll have the not equal to. So the only signs that can go here are greater than, less than, or not equal to. Those are the only signs that can go there. Those are your only 3 options. Does everyone get that? 3 options here. I want to see the 3 options in the chat. Put in the chat for 100,000 points. Your only 3 options for the alternative is what? But, oh, cool. That's awesome. Say hey to me. My email is just bstevens@utk.edu. So good to see you in the chat. That is my email. So good to see you here. So greater than, less than, not equal to, you got it. And make sure it's not equal to, the not equal to one. So greater than, less than, not equal to. You got it. Great answers in the chat. Thank you so much, everybody. There are only 3 options. Campbell is 100% right there. 100,000 for all these answers. So these are our only 3 options. Yep. This is the way I like to do it. And so when we look at this right here, the only thing we're going to change to the alternative is that middle sign. That's the only thing. So when we look at the question, do we see more, or do we have evidence for, see how it's evidence-based? When I say evidence, you should think the alternative. Do we have evidence that more than 70% of students like Taco Bell? Then right here, we're just going to put a greater than sign. We're just going to put a greater than sign. So here is your practice along. Let's do another example. Let's come up with a fake kind of null alternative to test. Let's see if the true proportion of students who like their steak, you guys know I'm always hungry, who like their steak cooked rare is greater than 20%. The true proportion of students who like their steak cooked rare, we're going to delete some of our notes and write this out of here so everyone can see in the future. So let's delete these notes and let's put it in here. Let's say, let's write a question. Here we go. Brian can't wait to order a steak again. We want to see if the true proportion of students who order a steak rare is greater than 20%. Write the null and alternative. Okay, so we've got our notes right here. People might already be putting in the chat. Now, which see some moves in the chat. I always like mentioning steak preference because it'll always get people be like yay or no or so I see. Oh, Lexi, great answer, Lexi. Lexi, you get 1,000,000 points right there because you specified, and Campbell's doing it too. But Lexi was the first person to specify that the null has the equal sign, and we see here the true proportion of students who like their steak rare is equal to 20%. I see a ton of the alternatives in chat. 100,000 points for all those alternatives. And we see here that the true proportion of students who like their steak rare is greater than 20%. Now, this is the way we set up our nulls. Very well, very well. This is the way we set up our null and our alternative. We simply write it out like this. And remember, we're not saying that the null is true. It's kind of just a jumping off point. It's like, here's what we currently are kind of going with as an assumption. Now let's see if we have evidence against this. So I want us to think, because we're going to get into the next examples here in the big part of the lecture. If you were to go out and talk to students, and you talk to 100 students, so we talk to 100 students, and 20, let's say exactly 20 of them order their steak rare. Let's just put up this. Is this odd, or is this unusual given the null? We will go deeper into this here in a moment, but I want us to think about this. You went out and talked to 100 students, and 20 of them order their steak rare. So what are you calculating right here? We've got here x. We've got here n. Remember, we're always big about our notation. So we need to put here that this is x, and this is n. And then you should see what you found. P hat, Walker, 100,000 points. Nice job. So we have million. Why not? We've been giving out huge points. So Melissa, also 1,000,000 points. Great job. You were second on one of those answers earlier. Great job. So we see here that x is 20 and n is 100. We have p hat. So yep, technically p hat. This is the sample proportion. So we would say here, is this unusual or is this not unusual? Campbell, amazing answer. He even knows we're not going to reject the null. 1,000,000 points right there. I'm going to turn, points are going down. We're going back to 100,000 for a moment. So we have here that this is not unusual. I just want you to think about this for a moment. We're not doing big statistics right now. We're just thinking about this. Is that what did you expect according to the null? I just want you to tell me, according to the null says that I should expect, if the null is true, what should I expect to see? If the null is true, what should I expect to see? Not unusual. Don't reject. You're right. If the null is true, well, I should probably see about 20%. What did I see in my sample? I saw 20%. Oh my gosh. Andrew, you might need to send me details on that. So we would see, good to see you, Mr. Moses. So we would see that, so the p hat does matter because what we see here is the p hat is 20%. So we see here that p hat is 20%. That's not unusual because we expected 20%. That's like saying, once again, going back to the innocent thing, if Brian is innocent, we'd expect him to like not be in New York and all these things, and that's what we saw. So we're going to continue to believe Brian is innocent. But what about if we saw, we'll just go crazy here. We're going to go, oh wait, we know one student. There's only one student. Okay, what is p hat now? What is p hat now? What is p hat now? Does anyone know what p hat is right now? It's 0.99, you're right. Now people are getting it. You're going to reject the null because like 99% of people in your sample want their steak rare. There's only one person. So, oh, that's awesome, Tracy. So now this would be unusual given the null. Does everyone see that right now? If the null is true, what should we expect? If the null, good to see you too. Thank you so much. If the null is true, we would expect 20%. Feel free to ask any question you have, Mr. Moses. If the null is true, we would expect 20% of people to like their steak rare in a sample. Does that make sense? If the null is true, we would expect 20%. What did we observe? We observed 99%. So is that unusual? If we expect 20% and we observe 99%, that's ridiculous. So if we expect 20%, we should probably see something close to 20%. It's all the quarantine time. So we will continue on here. Don't worry, they can feel free to ask questions that they want. And now let's continue on with the notes. Continuing on right here. Once again, our alternative hypothesis, huge thing right here, is the researcher's question. The alternative hypothesis, yeah, I'll get to that in a moment, Sarah. Great question, Sarah. We're going to do tons of examples, and I think you'll see it right here. So maybe let me hop back to it, make sure you understand completely. So when we're doing this example right here, and you said it, we're looking for evidence of something greater than, this is the evidence-based one. So the null is that it's equal to 20%. The alternative would be that it's greater than. Do we have evidence for the alternative? And the answer is yes. Now we'll do it mathematically here in a moment, but just looking at it, we would either say we have evidence for the alternative or we don't have evidence for the alternative. In this new example here, we definitely have evidence for it. I'll show it. I can show it mathematically, but this one is so much evidence that it's pretty easy to see without the use of p-values and z-scores. So we'll be hearing more p-values and z-scores in just a moment. So this example would be very unusual. Let's make sure it's very clear. This right here is very unusual, given 20% is the true proportion of students who want their steak cooked rare. That right there is very unusual. Does that make sense? If I change it to this right here, oh, that has 7, sorry about that. If I change it to this right here, this is not unusual. That's like not unusual at all. Does everyone see as I go right here, this becomes more and more and more unusual? Like if I increase it, this is just going to be more and more unusual given 20% is true. Exam 3 starts with chapter 14. Exam 3 starts with chapter 14. Great question right there. So I want to make sure this is very clear. I can't do anything but highlight it, put an arrow next to it. I can make this as clear as possible. But the biggest thing right here is that the researcher is going to come up with the question. When we do research, we say, let's see if, this is happening. We don't collect the data first and then come up with the data come up with the question after collecting the data. You always come up with a research question and then you say, now let's go investigate this question. Then you design things around it by how to investigate it. So the researcher always comes up with the question, and we'd come up with a question like, do 20% of students study in the library? So we could do that right there. And if you notice, we could test to see if more than 20%, and it would be the exact same question with P right here, because we want to know the true proportion of students who study in the library, it would be P. So mods, feel free to have fun. So with that in mind right here, let's continue on through the notes. Mods have a heyday with that. So with this right here, I'll let one of the mods figure out how to, let's continue on. Yeah, nice job, Caitlin and Abbott. And there's also a second button. If you do, check it out, mods. It's just a practice thing. Do you see, click the second name on it. And yep, you guys got it. Mods, you're learning about your superpowers. Oh, wait. Make sure to, yeah. So mods, make sure here, I'll do the final bit on here. It's like the third time, but we got it. Yeah. So great job, mods. Awesome work. That's why we have mod powers. Okay. Okay, let's continue on. I know, right? All right, so let's continue on right here. We've got right here that the true proportion is equal to 20%, and we have here that the true proportion is not equal to 20%. Huge note, good vibes. I agree 100%. We have here a very important thing right here. This is key. We have here that we have the null has the equal sign. The alternative has the does not equal sign. This is going to tell us what way to shade. Now, we're going to practice this a lot because it's like the remainder of the lecture. But what we will do is we will draw out our distribution. And does anyone see what's at the very center of the distribution? It's almost like previous chapters we've learned, where we have right here that if 20% of students, because that's what the null says, are students who, so we'll do that in a second here. If 20% of students go to the library to study, then what would we expect to see? Well, think right now. We're saying that P is equal to this, so P is going to go right there at the center. Does that make sense? If we say, well, I think the true proportion of students who would study at the library is 20%, that's my null, well, then I'd expect to see 20%. Does that make sense to everybody? If we would expect 20% of students. So P is going to be the null hypothesis. Well, it's what the value or the population parameter we're going to use right here. Good question right there. We have right here that P is the true proportion, and it says the true proportion of students who study at the library. P is just something we're going to test. And right now we're saying it's equal to 20%. And if P is equal to 20%, then what would we expect? We'd expect to see P. So we'd expect to see this right here. Does that make sense? That's the center of the distribution. Because we're saying, well, I expect that. And then what do we get? This 17% right here. This 17, thank you, Melissa. 100,000 points, Melissa and Tion right there. We expect to see 20% at the library. Yep. And then with this right here, what do we see? This is what we observed where? So this is what? How do we get P hat? This is just an example right here. P hat right here is going to be what we see in a sample. So P hat is going to be what we see in a sample. So P hat is going to be what we see in a sample. Exactly, the sample proportion. So, and please, if someone ever gets moderated and you feel it was unjustly, please email me and talk to me, especially on your UTK account. I'd hate to do that to a UTK student, but especially, and I appreciate all the people are always welcome in here with productive conversation. I appreciate it so much. So let's continue on. One thing I want to point out right here is that we have the does not equal sign. This is key. This is going to show us what way to shade. Take a huge note on this. I want to see it in the chat for 100,000 points. We're going to fill the chat with this right now. Is that the sign tells you what way to shade. The sign tells you what way to shade. 100,000 points right there. Type it in the chat while I take a drink of water. The sign tells you what way to shade. You need that note. You need to know that the sign, or specifically the sign of the alternative, Campbell right there, nice job. The sign of the alternative tells you what way to shade. Melissa, excellent work. These are key notes that you need to know that sign right there is telling you to shade in both directions. That's why this is shaded on the left and the right. So the sign tells you what way to shade. Excellent, excellent work right there. So this is how we're going to get p-values. The sign telling us what way to shade is going to be the key thing that is going to get us p-values. So when we do this right here, we're looking at our results and results more extreme than them. What? The p-value is the probability of our results or results more extreme having by random chance variation given that the null is true. Okay, don't need to know it like that. We need to know what it's doing though. The p-value is the probability of seeing something that we saw or something more extreme given that the null is true. The p-value is conditional on the null. So I want us to think about what it means to say the probability of seeing something or something more extreme due to random chance given that the null is true. When we did this earlier, let's go back to our example that we keep using throughout lecture. We have here 99. I want you to tell me, is this likely given the null is true or unlikely given the null is true? Remember, if the null is true, it's supposed to be 20%. So is 99 out of 100 likely given the null is true or unlikely given the null is true? I want to see in the chat for 100,000. Is 99 out of 100, it is unlikely given the null is true. So when you say unlikely, think about this. Winning the lottery is unlikely. It has a low probability. So when you think about saying this is unlikely given the null is true, you're saying, that's got a low probability given the null is true. Unlikely means low probability. Can anyone tell me what the p-value would be on the two-tailed test for this one? Can anyone tell me what the p-value would be on the two-tailed test for this one? The two-tailed test is the does not equal, so let me write that in here. Oh no, I swear I clicked the buttons, but they don't work sometimes, or it's user error. What would the p-value be on the two-tailed test, which is the does not equals? That is called two-tailed right there, or two-sided, and here's what it would be. I'll show you. 1,000,000 points, why not? First person get 1,000,000 points. And I'll give some hints if you're stuck. I think I'm doing polar extremes here. So I'm doing like opposite ends of the spectrum. We went from the something super unlikely to the most likely thing. This would be the most likely thing. Who can get it for 1,000,000 points? This would be the most likely thing. The most likely thing. I'm going to start writing out the answer. Keep thinking about it. If it's the most likely according to the null, it is the most likely according to the null. I've tricked everybody. Oh no. It is the most likely according to the null. So we landed our results were right here. This is where p hat landed. Now that below there, I don't see the answer yet. No one knows it. This is the most likely according to the null. The absolute most likely. Caitlin, million points, Caitlin, right there. Amazing answer, Caitlin. Caitlin got it right. It is the absolute most likely because you shade both sides. So I shade this side of it, and then I reflect over here and shade this side. We're going to be practicing this, don't worry. But does everyone see, and just think about this. This would be a p-value of 1 telling you that something at or above or below 20% would occur 100% of the time given 20% is true. Now, when would this p-value get smaller? Think about this. We haven't written real numbers on here, but if you landed further away, like theoretically if you landed over there, I'll take a quick guess. That might be around 40. Any statisticians watching this is just a guess. I should find out the standard deviation of it in just a moment, or the variation in it. But now this is further away, and here's what we're going to do is we're going to put a reflection over here, and now 40 is very what given the null is true. This is not an exact calculation, it's just an estimate, but 40 would be more what given the null is true. Just think about it without statistics, but 40 would be what? 40 would be, it would be what? Less likely. If people are saying less likely, that's 40 would be less likely given 20 is true. Because remember, 20 was the most likely thing given 20 is true. 40 would be, Macy right there, 100,000 points, and Julian, 100,000 points, put the right answer in the chat. 40 would be less likely given 20 is true. What is the most likely thing given 20 is true? 20. What is less likely? Things further away from it. And the probability of obtaining that, or something more extreme, is known as the what? Put it in the chat. This is all of our practice right here. The amount of shaded area under the curve is the what? The amount of shaded area under the curve, put it in the chat, I'm writing it, is the p-value. The amount of shaded area under the curve is the p-value, telling you how likely your result or result more extreme was due to random chance given the null is true. It's a lot to say, I realize that. But we're talking about, I'm going to highlight it as I say it, my results or a result more extreme, that's why we're shading, due to random chance, which is the curve itself, given that the null is true. The probability of our results or results more extreme happening by random chance variation given that the null is true. You don't have to memorize that, but that is what a p-value is. Nice answers in the chat. That is what a p-value is. So when the p-value is high, we're going to say it, just let the null fly. When the p-value is high, just let the null fly. When the p-value is low, reject the null. When the p-value is high, let the null fly. Just let it be. Don't do anything to it. Don't reject it. Do not reject. When the p-value is low, reject the null. When the p-value is low, reject the null. Those are key things because you're saying our results were not likely given the null was true. Or our results more extreme had by random chance variation given the null is true is unlikely. So you see it all right here. When the p-value is high, let the null fly. When the p-value is low, reject the null. Lexi, million points. Secret million points right there. Great note in the chat. Remember, put notes on the video too. Appreciate all those notes and all those suggestions. So we have only these key phrases. This is now a review right here that we only say we reject the null or we fail to reject the null. When the p-value is low, you reject the null. When the p-value is high, you just let it fly. When the p-value is low, you reject the null. When the p-value is high, you just let it fly. Big things right there. When the p-value is high, just let it fly. When the p-value is low, reject the null. Remember that. P-value low. We'll talk about what low means right here. Sorry, I almost went by that. Low means it's below 0.05. Now, that is what we call statistically significant. Statistically significant is unlikely by random chance, and statisticians a long time ago decided that 0.05 was kind of a good jumping off point. It's a 1 in 20 chance that your results or results more extreme occurred by random chance, but it's pretty unlikely. Now, what would you like if you reject the null? A really super small p-value or one super close to 0.05? If you reject the null, would you like a p-value really super small or super close to 0.05? What would be better? Million point question, why not? I said be big on points today. So what would you like? One that's super close to 0.05 or super small? If you want really good evidence. Smaller, exactly, Melissa, you are right for the million points. Super small. So what we want, and Rachel, great question, 100,000 Rachel also. We want, well, let me give the definition of statistical significance. Statistical significance means that something has a p-value less than 0.05, 0.05 or less. Don't worry, 0.05 is kind of one of those iffy things, especially when we get to upper statistics and we do more fun stuff. But 0.05 or less means statistically significant. So that is, you should remember that very, very big important note. 0.05 or below means statistical significance. Statistical significance also means that something was unlikely given the null is true. So when you think about unlikely given the null is true, that means low p-value. What is the threshold for statistical significance? 0.05. Andrew, 100,000 points. Keep those answers coming. So when the p-value is low, reject the null. When the p-value is high, just let it fly. Now, a big thing right here is you can actually change this. We'll talk about more in later chapters. I'm just going to put it here as a side note that this would be alpha, and you can change your alpha level. That is the later thing to come, but usually we use a 0.05 alpha. That is, so we'll put right here alpha equals 0.05 by default. That's horrible handwriting. It works though. So alpha is 0.05 usually, because that's kind of the general standard among statisticians. We've kind of agreed on it. It's like, okay, 0.05 is a good standard. We'll use that. So we will continue on here. So these are the three alternatives. Good stuff. So as you heard me saying, the two-sided alternative is the does not equals alternative. So we've got our two-sided alternative right here. And what do we get? Now here's the biggest thing. You have to go to your result, and then you have to reflect it on the other side. Does everyone see that? That we have our result, and then we're reflecting it on the other side. So wherever your result is, you kind of do a mirror image on it. But the good thing about this is all you have to do with your p-value right here is double it. So you can take your p-value and double it. So you can just double your p-value to get the answer for what the two-sided alternative p-value is. Let's take some big notes as we see this. You're going to see a big conceptual thing coming up right here. Here's your one-sided alternative. And guess what? The one-sided alternative, for 1,000,000 points again, can anyone tell me if we were to do the less than alternative, what would be the p-value here? If we were to do the less than alternative, what would be the p-value here? If we did the less than alternative, if we went less than our result, here's what we saw in our sample. What would be the less than alternative? We're just going to go less than that value this time. Who knows? Nope. No one's gotten it yet. It's a 1,000,000-point question out there. What would be the p-value? Remember, it's the area shaded under the curve. So the p-value is the area under the curve. So what would it be? Who knows? So what would be the less than alternative p-value? The less than alternative p-values are big questions, remember. Lauren, 1,000,000 points right there. Lauren is right because this is the p-value. That is the p-value right there. It's just that value right there. And then the two-sided, which is not on this slide, is where you double it. So does everyone see here's the less than alternative? Remember, the way it points is the way you shade the curve. You go to your result, and then you would shade the way it points. Here's another 1,000,000-point question. This is not on the screen, but can anyone tell me the greater than alternative? Who can tell me the greater than alternative right now? The p-value for the greater than alternative. Who can tell me the p-value for the greater than alternative? Think about this. I'll give hints while we do this. If the less than alternative is this, I don't see it yet. If the less than alternative is this, the greater than alternative would be over here. So what would be the greater than alternative? It's a complement type thing. It's like the complement. What would be the greater than alternative? Lexi, that would be the two-sided. Great answer, Lexi. That'd be the two-sided. Campbell got it. Campbell got it. Everyone's first person to put Campbell got it there, but who else can get it? You have to write the answer. So who knows the answer? Now people are getting it. 100,000 points for the answer, but there you go. Jayla. Nice job, Jayla. You put the full answer right there. Okay, I see. Great job, Lexi. That's it. Does everyone see that when you get your result, this is what you do, is you find your result, and then you either shade to the left if it's less than, and we're talking about this alternative right here, or you shade to the right if it's greater than, or if it's two-sided, you have to do a reflection of it. So if it's two-sided, you have to do a reflection of it to the other side. So you would double it. So whatever, you could do the lower side and just double it. But this is what we do. You look at the sign. If it's less than, you shade less than your result. If it's greater, or if it's two-sided, you shade both sides. And then two-sided is two-sided is double the smaller side. So if you get the smaller side, remember, don't double a bigger thing. You'll get more than one. But two-sided is double the smaller side. Excellent answer right there, Lexi. Great notes. So, and you guys are getting, does everyone see how we will choose the way we shade? What does the p-value mean again? It is the probability, and so I'll interpret this one. The probability, I'm going to say the general definition, then I'm going to interpret it in context. The p-value is the probability of our result or a result more extreme happening by random chance variation given that the null is true. So the p-value of 0.067 is there's a 6.7% probability of obtaining a result less than or equal to our result of 0.17 due to random chance variation given that 20% is true. So we would only see about 6.7% of the time a result occur due to random chance variation given a result less than 0.17 due to random chance variation given 0.2 is true. It's a pretty tough interpretation, but it's just telling us how likely something would be right here. This is the p-value telling us how likely results would be down here. Does that make sense, Campbell? It's a really tough definition. In my honors class, I literally have them write like a whole paragraph on interpreting it to make sure they can do it. I don't know how many people can actually interpret a p-value because it's usually like, yeah, that's just a statistical significance thing, but it's the probability of our results from our stream having a random chance variation given the null is true. But it doesn't help if you memorize it like that. You have to do it contextually like I just did a moment ago. So rerun the video if you want to hear the context on that again. But good practice. And Campbell, million-point question, big question right there. Great answer. That makes so much more sense. Yeah. Oh, that's Oh, we're in the sports shirt today. Thank you, Rachel. It's just telling us how likely something is. So when the p-value is high, you're like, well, that was likely given my null is true. So if something is likely given your null is true, would you reject your null? If what you saw was likely given your null is true, would you reject your null? Like you say, what I saw in my sample was likely given my null is true. Like this example, it's pretty likely. Would you reject the null if what you saw was likely given the null is true? Would you reject the null if what you saw was likely? Jayla, 100,000 points, Jayla, you are right. And Jake and Walker, keep those answers coming in. You would not reject the null. You would fail to reject it. Great answers. Woo! You guys get me stoked. Great class today. If they're blurry, make sure you click down below and you click the scroll wheel and you can increase the quality. So you can increase the quality. So here's how we do it. This is going to be huge for the remainder of the semester, and we've probably got enough time to do the remainder of the notes because we've been doing a lot of practice today. These are the 4 steps. We are going to write the null and alternative. Then we're going to pick, or we're going to do our assumptions. Then we are going to, which requires a model, we'll do the actual mathematics and we'll come to a conclusion. So let's do some practice with this. You ready? So when we write our null and alternative, this is huge review right here. We always have the null has the equal sign, and we did practice on this earlier, but this is write your null and alternative. Step 1, write your null and alternative. Step 2, we need to pick the right sort of test. Now we're going to do a 1 proportion z-test, which is the same name as the thing in the calculator. You can do a 1 prop z-test in the calculator. So take a note right now if you're doing the TI calculator, 1 prop z-test. And I've got videos on it. I can send you it if you need, but 1 prop z-test in the TI calculator. So we say, okay, we've got our null and alternative written. Now we're going to do a 1 prop z-test. Now you got it. Now we're going to actually do them. We're going to do the mathematics of it. Do we have that in step 2? We have it in step 2, do the mathematics. So we're actually going to solve this out right here. Let's take a look at this equation and make sure it makes sense. Do you know what's crazy? Do you remember back in the day, we had a z-score. And a z-score was simply observation minus mean over standard deviation. Let's take a look at this. This test right here on the right is what we observe in a sample, like an observation, minus what we expect. And if you notice right here, this is the null. This is the null value we hypothesize, so it's kind of what we expect. And then what are we doing to the bottom? What are we doing on the bottom? We are taking this difference up top and we are whatting it. The difference up top will be what? Like this difference is just going to be what? All we're doing is taking the difference and standardizing it. So we're going to standardize the difference. So remember, we're going to take a difference, like we're going to take this difference here and then standardize it and we get a z-score. That's what we did in chapter 5. Then we're going to take this difference right here and standardize it and get a z-score. Do you know what we'll do in the next chapter? Guess what? We'll take a difference from a mean. I'll write it this way for now. And that's the next chapter. Now, in the next chapter, all we'll do is we'll take a difference and standardize it. Does everyone see here that all of these T's and Z's, at least when they're used like this way, not for confidence roles, are just differences standardized? Take the difference, then standardize to get the z-score. It's very similar. All you're doing is saying, well, let's take a difference up top, and then let's standardize it. Yep, you see it. Nice job, Tion. 100,000 points right there. And then the standard deviation right here is going to be P naught times Q naught. Now, I know that's kind of confusing because we've had a lot of P naught, Q naught, P hat, P Q hat, PQ. So remember, you do get a formula sheet. It's probably one of my best bits of advice is you do get a formula sheet, but why is it P naught? Tell me right now, what is P naught assumed to be equal to? P naught is the hypothesized value. So P naught is just like the 20% I was doing a moment ago. It's just a hypothesized value. So what is P naught apparently equal to right now according to the null? According to the null, P naught is equal to, any ideas? P naught would be equal to, yep, it'd be equal to P. A little phlegm in my throat there. P naught would be equal to P. So we have right here, P naught is equal to P. So this is basically P times Q over N square root. Classic. That's why we memorize P times Q over N square root. All that good stuff right there. Now we simply just do the calculations. Like I was saying, just do the mathematics. And now we get the p-value. So now we got the p-value. And now we come to our conclusion. Biggest thing ever right now. Whenever you come to your conclusion, we keep saying it. You can only reject or fail to reject. You can only reject and you can only fail to reject. Those are your only two things you can do. Reject, fail to reject. Only two things you do. I think we got some examples coming up right here. Oh, we're doing hypothesis tests for the mean right now. They've combined these chapters on us. We're going to go slowly, and we'll be picking up this next time. This is a huge chapter. I tell you what, how about we'll stop here on these parts. Who wants to do a homework problem or two to finish off class for the last 10, 15 minutes? Who wants to do a homework problem? I know Melissa emailed me about one. Was it confidence intervals? I think we had some homework problem questions. This is a good spot to end. And I will put at the end of this video, you name the question, whoever names the question, be like, Brian, do this question. We'll do a homework problem here. Please work, my Pearson. What homework problem do you guys want to do? You have to be like, do chapter 14, 1 or 3. Okay, cool. Let's do it. And remember, I will go live more, and I'll probably be extending assignments. Does it have to be on chapter 15? Nope. Any sort of, we're going to do, yep. We'll try to do 2 or 3. Mean, confidence, quiz. Okay, we can do that one next. And I'll reorganize the quizzes. Sorry, as you guys know, my Pearson's been crazy lately. So I appreciate everyone being like I understand, Brian. They're being like, yeah, you guys have been really great. Oh, no. Please tell me. Don't do that, my Pearson. Don't do that. Work. Gave a random error. Assume, oh yeah, so let's do that. Amber's got that one right there. The one on chapter 14. Okay, so we'll do the pregnancy one. I think that's one due pretty recently. Let's do that one because we actually have, I think it's chapter 14. Okay. So I should have it up here in just a second. Assume that the pregnancies are normally distributed. Is that homework? Preview. And I'll try to make a more normalized schedule that you guys can know where I'll be. Oh, this is proportion, right? Wait. 13. Why did I click 13? I don't know which screen. Okay. Confidence rolls for mean. Sampling distribution for the mean. Okay, cool. This should do it. Here we go. And is the pregnancy one on here? Bank believes, waiter, CO2 emissions, and pregnancy. I think pregnancy's on the quiz. Let me get the quiz pregnancy one. And so just a moment. Sorry, the delay here. Oh, preview. So 1 moment, I should have it. Okay. Preparing a report on the economy. Send me as much as you can on that. This should have the... Here we go. Got it. Okay, we got the pregnancy one. Everyone is... Oh, thank you, Walker. Thank you very much, Walker. And we should be monetized soon. That'll be fun. Maybe that's why we had so many visitors today. I'll look and it's like, your channel's been monetized. Yeah, so here, Tracy, we'll do that one next here. So we should have enough time to do both of these. So assume that the duration of human pregnancies is normally distributed with a mean of this and a standard deviation of this. So once you hear mean and standard deviation, immediately identify that these are mu and sigma. So we need to bring up our old friend, Mr. David M. Lane. Maybe it was David M. Lane visiting us today. But we have here, I think it was 262 and 11. I think that was it. We'll check here in a moment. But we're just putting in the mean and standard deviation for these. And yes, it was 262 and 11. So we want the percent of pregnancies that are between 275 and 180. So we're going to go here to this one. And we have to get the areas between these. So 275 to 280. Now this problem right here is a chapter... Oh, really? Oh, I didn't click the button. This is a chapter 5 problems. Oh, thanks. It tells who subscribes. Thank you. That's so cool. So thank you for subbing. We have 1 sub. We'll take it. So we have right here that we have between this is this probability. And that's kind of like a p-value again. It's similar thing. It's telling us the probability of pregnancies between this range. Does that make sense with like today's topic? Like the probability of pregnancies between this range is this. So it's kind of like a p-value. It's not a statistical test, but it's kind of telling us the probability. And that's what the curve tells us, that that's how likely this was right here. Now we want the longest 25% of pregnancies. We get right here, and we go to this one, and we go, turn on that bell. Well, Carson knows about this YouTube game. So now this is the longest 25% of pregnancies. Now here, if you notice I'm doing this problem a little quickly, but we're about to get to the big important part of this problem where it changes. Everything we just did right here is a review problem. Hopefully I'm not going too quickly and I'm getting it right. Everything we just did is a review problem. Now the problem switches. The problem is now the sampling distribution of the sample mean. And so when we do the sampling distribution of the sample mean, we have to know our notation. We have to know that the mean for the distribution of the sample mean is equal to the mean. The standard deviation for the distribution of the sample mean is equal to sigma over square root of n. Now in this problem, we already identified that mu is 262 and sigma is equal to 11. We didn't have to know the sample size until we start doing the distribution of the sample mean, because every sample mean has with it a sample size. So we need to now know that sample size, and we go back here to our notes, and we can put in a sample size of 90. So now with all this information, we put in the values. One of these days I'll learn how to use this pen. One of these days. We go here, and this is 262, and this is 11 over square root of 90. So make sure to have your notation out for the chapter and identify each part of the question, because once we put the notation here, we're able to pretty easily identify what it is. Now, it's hard without the equations and knowing what each thing is, but now we've solved for the mean and for the standard deviation. So we've achieved the notation. Thank you. Awesome. Yeah, go take the test. Great job, Melissa. So, and we'll try to do another question here in a moment. I think we got just enough time to do one more. And so now we go back here. The mean is still the mean, because remember, if one pregnancy is 262, we'd expect a bunch of pregnancies to be that. So, oh, such positivity in the chat. 100,000 Melissa and Carson right there. So, and Tracy, all this positivity. So let's go and do 90 square root 11 divided by 90. And so that's the new standard deviation, round to 2 decimals, 1.16. And then we go right here. What is the probability of a pregnancy lasting longer than 261 days? Oh, we can take a good guess at this. It's probably, I'm not going to check it, but does everyone notice that the new standard deviation, 261, is a little less than 1 standard deviation? So it's probably going to be about, I'm going to guess that. TL at 100,000 voice. I like that right there. So we're going to get the new standard deviation right here. Hopefully I did this. Less than, no, why didn't I read less than? I was like, I'm going to do the wrong way. So I'm going to do the complement of that. Okay, let's see. Let's see how close I was on my answer. That was a guess, and then I forgot to do less than. So we go here, we change the standard deviation, and we go below 261 and 19.4. So I put this, and it's actually 19.4. So I was pretty close. That was a guess, though. You can guess if you want, but check your answer. Let's check our answer. Did Brian get everything right? 80%. Uh-oh. Round to 3 decimals, round to 2 decimals. Where did round to 1 decimal? Could you email Brian and get your points back on that? You could. You know how it works. If you get off by a decimal, make sure to check your decimals. But I put in too many decimals. We know what happens. If you have in the chat emailed me because you did something like that and got your points back, I want you to be like, that's me. You don't have to say it if you don't want. But who's had that happen and got their points back when you email me and say, hey, Brian, I put in an extra decimal and it didn't like it. Have I ever helped you out with that? Feel like, no, Brian never does that. Yes, sir. I like that right there. I'm not a sir. I'm only 20 years old. People don't believe that. Me right there. I like that. He's be like, hey, Brian, I put in 1 too many decimals. Give me my points back. Don't say give me. Someone's going to say that now. But yeah. Do we have time for one more? I think we do. Let's see right here. That's the one I emailed about the 5%. What does that one start with, Tracy? It's confidence intervals. We have just enough time to do that. Tion says no. Tion, 100,000 points. Yeah. You guys crack me up. I hope you guys have. Did you guys have fun in class today? We're gonna pull up the confidence interval one right here. So that's got to be confidence intervals. The waist size one. I think I did that one. I did that one just yesterday, Kara. check out yesterday's video, and I've got a full video on that. So you'll see it at the start of one of yesterday's videos, I think. So check out that one. I don't think it'll let you do that because it's locked down. Yeah. So print it out if you can, or write it down. And also the screen's don't do that because lockdown browser will get mad at you. It'll flag you a lot. Editors preparing a report. Okay, cool. Let's do that one. We got just enough time. So we need to go to confidence intervals for the proportion. Great questions. And I'll always try to do, and I might do other questions at the end of the next video. So, no, got to go to look at all questions. My Pearson, keep working all day. So confidence intervals for proportions. And we want to do the quiz, replace questions. And 2 seconds, we'll have it here. I just have to find it. How many random assignment probabilities will they need to contact? Cool. Let's do that. Okay. Let's see if we can find it. No, my Pearson. Don't do this. Okay. Philanthropic. Vitamin D. Is believed to graduate from high school. Okay, here we go. We got it. Okay. Got just enough time. Okay. So here we are. Editors preparing a report for the economy are trying to estimate the percent of business they need to hire employees in the next 60 days. They're willing to accept a margin of error with a confidence of 95%. Okay, so let's grab our question here and start taking notes on it. And we are going to copy paste this question. Cool. So this question is tricky for really one part of it. There's one part that I think really gets people. So what we have here, let's put our notes. We always like to write on our questions, make sure we know what we got. That is the margin of error. So we have here the margin of error. You're welcome, Walker. Good seeing you today. And this here is going to be the confidence level. And from this, we get the z-score. So from the confidence level, we get a z-score, and we know 1.96 by now. So the z-score is 1.96. If you're wondering how I got that, you can go to the David M. Lane applet. You can do a confidence interval right here of 95%. We're going to shade the between area, and we put in 0, 1, because those are for z-scores, and we get 1.96. It's a very classic number. Yeah, if you can't find it, Kara, email me, and I can email you right after class, and I'll make sure you have it. So great answers in the chat. Walker and Carson, you guys bring so much positivity. It's awesome. I miss seeing you over there on the side of the class. There we go. And so we have here the margin of error. We have here the confidence level. We have here the z-score. And now we want to know the sample size needed for this margin of error. So let's go ahead and write out the margin of error. The margin of error, just so if you're wondering, we have the margin of error right here is the following part of the formula. I forgot a hat. The margin of error is this part of the formula right here. That is the margin of error. So we're going to set this equal to 0.05 because it's a proportion. Proportions are decimals, percentages are percentages, but you can flip. Just make sure you keep using the same one. And then we're going to set this equal to 1.96 square root. Now, it doesn't give a p-hat, so the safest assumption, which is what we should use, is 0.5. It just doesn't tell us it, so we have to assume, which is fun. And then we take this right here. Now, the really great thing about this is 0.5 times 0.5 is 0.25. So I'm going to go ahead and solve part of this right here, that we get 0.05 divided by 1.96 equals 0.25. I'm just solving the inside of that, and then we get n square root, and then we go over to here, that this would simply be, we square this side of it, so we get 0.05 squared, or 1.96 squared, equals 0.25, and then we go here over n, and then we cross multiply, or whatever it's called, to make sure it's on the other side. We're just doing algebra right now, so algebra is the least fun part of statistics. So we go over here and we put n over here, and we put 0.25 right here, and then we put the following, 0.05 over 1.96. Now what we can do to make this nice is we can use space pen and write out what n will be. N will be equal to p hat times q hat over squared z, no, it's not z. I hate that it does that. And me over z. And that's got it right there. Does that make sense right there, Tracy? That should be the answer. And there's the formula to find n when we put it back into notation. Because the 0.25 was p hat times q hat. Is there anything that needs to be downloaded for Lockdown Browser? When you go to it, do the practice one first. It's a very, very simple thing, Tion. So do the practice one, and you got it, Tracy. You got it better. Good job. It's solving using the formula to solve the margin of error. Oh man, my fiance and I were recently watching Rugrats again, and it's so good. Old Rugrats is so good. Man, that show is like, it was beyond its time. I know a lot of people say that about stuff, but that was like such a good, watching babies make like intellectual humor and adults just acting like babies was like, or I don't know. The show was very well written. Amazing. A show about, like babies experiencing the world. It's such a cool concept. Yep. Well, that's got it. I'm going to grab some more water here and grab a little food, and I'll be back. So if you want more questions, you have more stuff, remember, we will do more facts. Oh, I like that right there, Tion. So, and I think, yeah. So subscribe, like, say hey. Thank you for your lecture. Super helpful. Glad to hear that, Campbell. Keep asking those questions. Remember, I'm going to put out a schedule this week of when I'll be live. The show was so well written. So are you getting online again today? I might later on. Maybe a lot more Wednesday. Sorry I'm taking so long to get the schedule out. We're going to have some Stat Lab worker people, so expect some more help and everything coming soon. I'll see everyone later. I'll be back. So if you're watching this right now, I will be back. Just going to get some water and be back here in a moment. See everyone again. I'll be back alive in 10 minutes. Hey everybody, we're back now, and I see we have a fan favorite in the chat. So yeah, we got Kid PvP and we got Calzone. So good to see you. So you can use sorry, it's been I know, so good to see you. Hope you're doing all right, and I'm wearing my sports shirt today. But sorry for all the conflicting information. We had some instructors saying yes, some instructors saying no, and then people were getting really confused. And I was saying no to everybody. But we really don't believe a calculator will be any addition. There's not big calculations on the test. So for those who have taken the test, it's not very, very calculator intensive. There's a lot of true false, a lot of multiple choice. So it's mainly important to know your theory stuff. And here's the thing, probably one of the biggest tips. Oh, we need Rick and Morty to start class. Oh, I'm so sorry. Let's do it. Let's do this.
Like TV from other dimensions has a somewhat looser feel to it.
Yeah, it's got an almost improvisational tone.
There we go. We got some Rick and Morty in. We need Rick and Morty. So the calculator on the screen works really well, and that's the biggest thing is I don't think anyone will be benefited by using a regular calculator. The calculator on the screen, there's not big calculations we're doing on this test. Great questions, and so good to see everybody. Hey, Isabella, and so good to see Calzone. I saw Calzone, and he's just favorite. You're welcome, Abby. So I've told the story of Calzone multiple times that we were doing the Kahoot, and he joined in, and but remember, here's the biggest thing. I know a lot of people have emailed me about their exam scores. Remember, it's averaged with your quiz score. So if you have 100 on your quiz score, then even if you make a 60, you'll have an 80. If you make a 70, you have an 85. So the biggest thing is it's averaged with it. And we are going to look at the averages after the test occurs to see if any other things need to be done. Make sure to take it today. Just 13 and 14 open right now. And I might be probably changing around 14 due to all the Mike Pearson issues. But remember, 13 was extended due to Sunday having issues. As long as everything goes well tonight, we should be all right. Because it was only crashed for like the later part of Sunday. If it crashes again today, then it will be extended until we get like a full day of it open, because the crashing only started on Sunday and hit Monday also. So we want like a full day of it being open. It's more like a lot of, and this is so key. So here's a big thing, and I've been stressing this a lot. A lot of the theory things you're going to hear me go through today, a lot of the things and the way I'm going to teach it is going to be very similar to the exam. The exam has a lot more theory questions with true, false, multiple choice questions. Yep. And so exactly. Remember, we're going to take the higher one right there. What if the quiz? Yeah, exactly. KO, great question. So your quiz average cannot bring you down. It's only going to be the higher one. So thank you, Harley. 100,000 points, or 1,000,000 points. We were getting out 1,000,000 points earlier. We're going to do it again for this class. Remember, I said huge points. Please keep attending live. I can't say that. If you say hello in the chat right now, just make sure you're here. You get 100,000 points. Who's here in the chat? Say hello to me. Say hello to someone else. Say hello to your friend in the class. Who's here? Is Calzone still here? Give Calzone 100,000 points. Who's here? We got Hunter. We got Carlos. Who else is here? So we got, wow, here's everybody right here. To the quiz, yes, the quiz average includes the drop, Neely. Great question right there. And Nerd, tag me. So, and I'll see the question. We got people saying hello. Good to see everybody. Still here, Abigail. It's good to have you here. So I love it. Love everyone being here. So remember, you can tag people right here. I love it. I love people tagging each other and saying, hey. So biggest thing right here, good to see you, Roderick and Caleb, and people tagging me and Logan and everyone else. So be here, be interacting, be live, because you need to have your notebook out beside you, as we've been doing all semester. Playing Halo Reach. Put down the Halo Reach for a second. Can't wait to see the answers on this test. Yep, the answers will appear Sunday, so I can't send out answers yet, and then they will appear, and you'll get to see how you did. So great stuff right here. What did Kid PvP say? I missed it. But good stuff in the chat, and so good to have everyone here. Did I miss it? I missed it. So awesome stuff. I know it's a little tricky. Remember, it's a big thing, your quiz average. So if you can do chapter 13 and increase your grade, do the chapter 13 quizzes, and it'll definitely help your grade. And then we're going to look at the average. So here's the biggest thing. Since I am the coordinator, here's what we're going to do. The average for test 2 is usually about a 75. So when we get the average for this test, if it's something like a 65 or a 60, there will be a curve. And remember, this is after we do the already curve. But if we see that the average is really low, we will be curving it again. We will do something because this is our first time doing this with the big online thing. So just chapter 13 is due tonight, and I'll be moving around chapter 14. I'm going to adjust some due dates on this. It's only the chapter 13s are open. I know it's like that's what we agreed upon as all the instructors. The exam is pretty tough. And so the biggest thing is we will be looking at the average. If it's like a 75, there'll probably be no curve. Like that's highly likely. If it's a 75, like it's usually been throughout semesters, then things are on par for what the test average is. If it's something like a 60, well, then we're going to curve it because then this test didn't do the same sort of metric we usually try to get. So we will try to put everyone to the same metric we've been doing. And then remember, no, Logan. Oh, right there, Logan. Logan's just like, make sure everyone get a 60. I mean, you just don't do Good bad advice there, Logan. So any other questions right now before we start class? Good stuff going on right here. We'll test 3B average. We might do the same. We're definitely going to try to keep the tests on the same scale as they've always been. So expect that if we were not averaging this one with the quizzes, then if we were not averaging, I can't do that. If we were not averaging this one with the quizzes, there would definitely be a curve. So what we wanted with this sort of curve is to benefit everybody who's working really hard. So this curve, the first curve we're putting on it, I don't know if there'll be a second. We have to see test scores. But this curve right here helps the people the most who are working on the quizzes. Now, there's opportunities on quizzes still open. Does that make sense? That's our theory behind it. It's like the people who are working really hard, we want to give them the most benefit, and we want other people to still have the opportunity to work hard. And there's one quiz drop to this section right here. Step 49. You got to do it via Zoom, though. You got to do it via Zoom. What does the Section 2 quiz grade average mean? It is your averages on the randomness quiz, the sampling quiz. You should see it in My Pearson. Has anyone found in My Pearson where it has like Section 2 average? So there should be a Section 2 average in My Pearson, and you can look right there. There's one drop, and it already includes that. So when you see your Section 2 average in My Pearson, it should include that one drop, and that's what we'll be averaging together. Does that make sense to everybody right there? How are we doing all that? I think we should be good. That gets us like ready to go for the day. Today is a huge topic. Today is is it possible some answers on test 2 could be misgraded? Yeah, tell us if you see something weird. We'll probably let people go back and review, like we'll have a review period. Let's say there was a decimal issue. We'll talk about that as instructors. So really great question right there. If there was a decimal issue and it wasn't counted correctly, we can let you review it. Hey, review your test. And we'll probably say within this week period, review it because it'll only be open for you to view for a week. So please tell us if there's an issue, take screenshots. We'll probably have a procedure, or I might just like do a video, be like, make sure you send us a screenshot. We'll verify the screenshots. I know, Zach, that's sad, Zach, because this is big stuff right here because the concepts we're about to do right now are huge. So make sure to keep showing up live. Everyone who's watching live right now, I want you to type 1 million points in the chat because you just got 1 million points. Only if you type it, though. You got to be watching live right now and listening to what we're saying and be ready to type something. I want to see 1 million points in the chat for all those people watching live who just got 1 million points. Yes, Nicolette and Kid PvP. All these people are getting their million points because they're watching live and they're interacting with class. I love all these answers right here. So please, easy 1 million. Calzone got that easy 1 million right there. So keep interacting. I'm going to keep throwing out big points. We got a lot of big questions today. Keep showing up live. I know it's easy to say I'll just watch this later, but you can watch it later and review. It's really important. It's regular things are 100,000 now, and million is me getting you guys to do something I really want you to do. So I really want people here live, and I think I almost left. Good to see you, Aaron. Keep reviewing. Oliver, I can email me and I'll send you it, and I'll be broadcasting. And then I looked and I have like 40 or 50 emails to get to when I finish this. Points and oh no, did people already leave? Every time I give 1 million points, we lose like 10 people. So we love the point inflation. It gets more important at the end of the semester to stay and watch. If we get an A in this class, can we make it credit? Don't do that. I don't know how all the credit, no credit stuff works. Deep breath. Practice test is not for a grade. You are correct. Practice test is not for a grade. So here we go. It is time to start. You just got it for being here because you're awesome. You're welcome very much. Thank you, Macy, right there. It is time to start the new material. Zach's even put down Halo Reach for this. He's gonna beat the flood, I think it is. Today is about testing hypotheses. This lecture is a crucial one because it sets your foundation of knowledge for about 3 more chapters. This is like the remainder of the semester right here. You got to clue in, you got to have your notebook out, and be ready to take down notes on this. Here we go. Oh no, that's horrible, Zach. I'm sorry to hear that. Let's start writing out our hypotheses right here. Here we go, writing down our hypotheses. Rachel's got it. 100,000 for Rachel right there. Notebook out. When we think about court trials in the United States, 100,000 both right there. When we think about court trials in the United States, we have an assumption we start with. For 100,000 points, do we assume that people are innocent or guilty in the United States to start? Do you assume that people are innocent or guilty in the United States to start? What do we assume to start? That people are innocent or people are guilty? Not guilty right there. You got it. 100,000 points. Keep those answers coming in. Don't assume guilty. Don't assume guilty. We're going to start that somebody is innocent. This is our null hypothesis. Our null hypothesis that someone is not guilty is our starting off point. So with this in mind right here, and I like it, Sophie gets an extra 100,000 on top of the original 100,000 everyone's getting because she said innocent until proven guilty. That's what we do. So let's start thinking about this. I've already got some notes. Yeah, I want to do new notes. I always like writing them out with you guys so we can think about them. So we have 2 competing hypotheses here. We have a first hypothesis that someone is innocent, or we could do it as complements as you guys were doing. The start is not guilty. And the alternative to that is guilty. Here's the key thing in statistics. The key thing about statistics is we need to call one of these the null. And the null hypothesis is what you start out with. Yeah, there's a lot of people who are pretty much assumed guilty. You are right, Zach. 100,000 Zach right there. So we have here, right there, we have the null hypothesis and we have the alternative hypothesis. The null hypothesis has an O on it. If you can't see, this is an O right here. This is a little A right there. You can do it as a big A too if you want. Just make it kind of clear that that's an A. We're just making sure that people know that the null is our starting off, jumping off point. So we'll put a big O right there, and then we'll put a capital A down here. Sometimes people even put a 1. Do you think... I have no idea there. That is above my pay grade. So we have right here that we have guilty as the alternative to not guilty. So what do we need? We need to do this in statistical notation. Julio gets 100,000 right here. Huge notes. Because I want us to think about this. Let's do this another way. Let's ask a totally different question, but let's think about it with statistics. You ready? Let's try to see if 20% of students like their steak rare. Now this is where it gets tricky and we're going to need some help with this. We're going to need to learn how to write our null hypothesis right here. Are you ready? 20% of students like their null rare. Like their steak rare. Best way to get your steak cooked, some more medium rare, but we'll go rare right now. So let's think about this. When we write out the null and the alternative, first we write the null, and what do? We write first the population parameter. I gave 1,000,000 points last class and no one got this. Someone from last class is going to get this by staying, but I think it took a while. I'll give 1,000,000 points for each population parameter someone puts in the chat. You have to be first, but I want to see a population parameter in the chat. It has to be in notation, like a notation for a population parameter would be what? What is a notation for a population parameter? We have to understand what this whole thing says. Anyone have any ideas for 1,000,000 points? These are big ones. It is population parameter. What is the no? So what is it? What is it? Here's how I'll make it mod. Mu. Caleb got it with mu. Caleb, excellent work. Caleb is right. Caleb got mu, and I already see P. I think they're so quick. Abigail got P, so Caleb and Abigail get 1,000,000. And wow, the first 2 answers. Who likes their steaks rare? A few people. That's who. So we got here mu And we've got here P, and there's a secret one no one's gotten yet. I'll take sigma from kid PvP. We won't do that one in the class, but that's 1,000,000 points right there. So sigma is also one. We don't really use sigma in this, but sigma is an answer from kid PvP. Nice job. And then the last one we will test in this class will be, I don't know if anyone will get it, mu1 minus mu2. So the last one we will test in this class is mu1 minus mu2. So these are the population parameters we will test in this class. And there's other ones. Julio put for 1,000,000 points Q. That is correct. That is another population parameter. We won't test that one because we're kind of testing it by testing P, but that's another population parameter. So the population parameters we will do tests on in this class. Where'd Space Pen go? You gotta be kidding me. Where'd Space Pen go? They took our Space Pen. Oh, that is so sad. I used it too much and it went away. So we have right here that these go here. So there are 3, 1. Space Pen is on Halo Reach. I like that, Zach. So those are the 3 right there. Rip Space Pen. F in chat for Space Pen. F in chat for Space Pen. So it'll come back next. It'll return in next. Space Pen will return in Stat 2.0. So we have right here the 3 different population parameters we'll be doing in this class. You guys are awesome. 100,000 for everyone paying respects to Space Pen right there. So these are the 3 things that go here. Now what goes over here? A hypothesized, no, it's not doing that. A hypothesized value is what goes over here. A hypothesized value can be pretty much any value. Now there's things it can't be. You can't say negative 0.5 is the proportion because proportions are between 0 and 1. So I want you to listen in closely because I'm going to start giving problems right here. And I want you, and we're going to cheat and use some of the notes from last class. We're going to go over here to the notes from last class and go back in time and use one of the things I wrote to help us out. Oh, did I lose it? I think it's this one. Okay. So we're going to go back in time. Hopefully I can go back far enough. Perfect. This is what we want. Okay. Here we are. How many population parameters are we going to use in this class? How many population parameters are we going to use in this class? How many different population parameters are there? How many different population parameters? There's 3. Elizabeth right there, 1,000,000 points. That was a secret 1,000,000. You got it, though. So you are right. It is 3 population parameters. So whenever you do this first part of this question, you have to listen in. Please listen in to what I'm about to say, and you should decide, is it mu, is it p, or is it mu1 minus mu2? Now, if you're confused about which one is which, there's no bar on that mu. That's not a y bar. Mu1 minus mu2. So listen into the question, and I think you'll get it. Now, Julio gave us a great bit of advice. He said the null has the equal sign, and this is whatever we hypothesize over here. This is the hypothesized value. So the null always has the equal sign. So let's test this out and see if you guys can get it. We want to test to see if the proportion of students who like Taco Bell, I'm putting a trick in here, is greater than 70%. We want to see if the proportion of students who like Taco Bell, 1,000,000 points for the first person who writes the null in the chat. We want to see if the proportion of people who like Taco Bell is greater than 70%. The whole thing, you got to write the whole thing, the whole null. You don't have to write the HO, but you got to write the whole thing. Everyone's saying P, 100,000 points for those Ps, but what's the whole thing? You are correct, it is P. So what's the whole thing? Taco Bell always. We're all about Taco Bell in this class. Maybe one day I'll get sponsored by Taco Bell. This semester is the Taco Bell sponsorship. Everyone's putting P, but what's the whole null? Abby gets the 1,000,000. Abby, great job. You were first right there. You got it. I'm also throwing it to Kelsey and Catherine and Kaylee and Madison. There we go right there. And Julio gets the whole thing for 1,000,000. He already knows the full tricks on these. Wait, Julio, you forgot the P's. You only get 500,000 for that. So remember, we need here to put the true proportion right there. So great job, because I gave you a trick to this one. And not many people, I don't think anyone was really tricked by it, because we need to make sure that we remember the null has the equal sign. That was a huge tip right there. Don't worry. This is why it's practice. This is why we practice. We have to write 3 things. We have to write the population parameter. We have to put the sign, and then we have to put the value we're testing. So even if I try to trick you by saying, let's see if more than 70% of students like Taco Bell, I want to see it for 100,000 points. The null has the equal sign. The null has the equal sign. Put it in the chat for 100,000 points. The null has the equal sign. We had someone visiting from Cincinnati Statistics, and they wrote that out before I told everyone. We pretty much chant that the null has the equal sign. So the null has the equal sign. Cincinnati, excellent work. The null has the equal sign. We know that the null always has the equal sign. Yes, I love when in the chat just everyone's putting the answers in there. So guess what? Do you know the only thing that changes between the null and the alternative? Check this out. If the alternative is a claim that we're going to come up with, so we've got the alternative down here, the only thing that changes for 1,000,000 points is the what? The only thing that'll change is the what? Who knows what will change when we do the alternative? Any ideas? Oh, that was highlighted. Not the value. Who knows? The equal sign, Jacob right there got the 1,000,000. Jacob, excellent work. And we're going with Caleb and also Snay and Julio and Kelsey get the 1,000,000. Everyone else gets 100,000. Hopefully I said everyone who got it. But watch, as we write our question about Taco Bell, that we want to test if the true proportion of students who like Taco Bell is greater than 70%. Don't be tricked. The null has the equal sign. This one has the direction to it. Notice that the only thing different right here is the sign. The only thing different is the sign. What if I wanted to test that less than 70% of students like Taco Bell? Well, then we go right here and we just change the sign in the middle to see if there's evidence that less than. We could also test that it's not the case that 70% of students like Taco Bell with not equal to. So let's try a few more problems here. You ready? I want to see first person gets 1,000,000. We're going to keep it that way for a little bit so I don't do too much point inflation. But I want to see the null hypothesis, because if you write the null, you can write the alternative for each question I ask you. Let's see if the average age of UT students is equal to 20. Let's see if the average age of UT students is equal to 20. Who's got the null for that? Who can write the null to see if the average age... careful. Reagan got it. Reagan, really quick right there. Right answer. So we write out, and always try to read it, that the null states that the true mean age of UT students is equal to 20. Now, the alternative would have a sign right there. We would have the alternative be something like, well, is it not equal to 20? So the alternative would just change the sign right here. Does everyone see? Why is it mu instead of p? Great question, Zach, for 100,000 points. This one is testing quantitative data, and the other one was the proportion. So this is the true mean age of students, which is quantitative, and the other one was the proportion of students who like Taco Bell. So if you ask a student about Taco Bell, you have to ask, do you like Taco Bell, yes or no? But if you ask a student about their age, you'd say, how old are you, which is quantitative. So these two ones up here deal with quantitative data, and this one down here deals with categorical. So proportion is P and quantitative is mu. That is correct. Abby, 100,000 points. Great note in the chat right there. And then if you notice, let's throw the trick out there. What about if we want to test the age of UT students versus the age of Florida students? Who can tell me in the chat what the null is to see if we want to test the age of UT students versus the age of Florida students? Remember, we're kind of working through everything we have written here. So we're testing UT students. Write the full thing. I'll give you the 1,000,000 for that. You're super quick. But write the full thing. Someone else has to write the full thing to get 1,000,000. So you have to write, I'll give you the HO. But we got Caleb right there. Caleb, amazing work. mu1 minus mu2 equals 0. So that's what we're testing right there. The population parameter is what we're interested in testing exactly. So we have here, everyone else getting the 100,000 points. This is really good practice. You need to remember when writing your null and alternative that there's 3 parts to it. The first thing is what you're testing, the population parameter. So we're testing the difference between the age of 2 groups. Remember that mu means mean. This is mean of group 1 minus mean of group 2. So that's the difference between the means of the groups. Well, what's the difference between the groups? We're going to try to investigate that. We're saying that that is equal to 0, as in there's no difference. And then we could do for the alternative down here, mu1 minus mu2, we could say not equal to 0. So let's do one more example right here, see if everyone gets it. Please ask questions if you have it. You guys are doing amazingly well. The other class, I just think more people are answering. I don't know, but man, you guys, everyone's like giving right answers so quickly. Or you're watching the answers. You know how to do the online class. They just copy it. But either way, I'm very proud. So proud of all my students. And so what do we have right here? We have right here that let's say we want to test the proportion of students who own animals, and we want to see if it's more than half. So what would be the null for, let's see if the proportion of students who own animals is more than half. Any ideas on that? We want to do a test to see if the proportion of students who are in animals is more than a half. Remember, write the whole thing. You got the null right there. Sinead's got the null for a million right there. First person to get the null space pen is back. So we already got space pen on here. We've got P equals to this. What would be the alternative? So here's the hard part. You're going to have a hard time writing this. But remember, the null only has the equal sign. So I never gave sidedness to it. Oh, did I say more than half? I think I did. Whoops. Who got it first? I do not know. I think Julio might have been the only one who put HA on it. I don't know. Well, if you're putting it in million, if you put the greater than 0.5. So sorry, everyone's putting the null alternative at the same time. Now remember, we're only going to have 3 choices right here. I saw someone write out all 3 one time because I do it like this sometimes. We've got the less than, greater than, and not equal to. Don't put all 3 in there, but those are the only choices. You won't use all 3. You'll let the question dictate which way it goes. So don't put all 3, but those are your choices right there, right now. So everything right here is things we've been talking about, that the null hypothesis is going to test a population parameter. Do another one with mu1 minus mu2. Yeah, here we'll do the alternative, and they'll do another mu1 minus mu2, which is like one of our last chapters in the class. So if you're learning this right now and you know the differences, you're like getting super prepared for the final. I say this and I mean this. The final has a lot of confidence intervals and a lot of statistical testing. You have to know this stuff pretty well. Like you have to follow along, know how to do statistical testing, and then you'll do well in the final. So do not skip these lectures. Please don't skip them. Watch them. Okay. So here's our notation on how to do the alternative. If you notice, the only thing that changes between this slide right here and this slide right here, we erase that. The only thing that changed between these slides was just the sign. And the null always has the equal sign. If the p-value is low, reject the null. If the p-value is high, just let it fly. The only thing right here, 100,000 points for that right there. So the only thing that's changing is the sign. So Zach wants another. And here's where you know you really, really know it, is if you can come up here with your own question. So whenever you do, I want for 2 million points. Only one person gets this. But for 2 million points, I'll say your name in chat, think about what we have right here. We have this, and then we have this. And both of them are means. So what do we have right here? What would be a question? So think about this. I want you to be thinking about this, and how would we write this question? We want to test what? We want to test, think about what this word means right here. You're subtracting things. We want to test a something between two somethings. Yeah, but you got to give a full question. You got to give everyone's got to be like a full question. You're getting it. These are a difference between 2 means. You're getting it. That's awesome. I want to see a full question for 2 million points. Someone's going to have to type out a pretty big thing right here. What's the difference between pretty much, oh wait, Brian got it, I think, the height of male students and the height of female students. Boom. So yes, I'm going to give 1 million points to everyone answering up to, Rachel, down to Rachel gets 1 million. And then I think it was Brian was first, gets 2 million. So it looks like most of these answers are correct right here. Test differences so yeah, you want to have 2 groups. Does this make sense right here? You have 2 groups. Like we see right here, the difference in the number of Skittles per bag and the number of M&Ms per bag. Yes, the mean difference between Skittles and M&Ms. You got to make sure to give a full answer. You got to make sure to say, let's compare the average amount of M&Ms you get in a bag versus the average amount of Skittles. That'd be such a cool question. Like, are you guys interested in that? Like, which bag on average gives you more? And then you would go right here. I think that's a really great one because I wish we could bring Skittles and M&Ms to class right now and just eat them all. But if you look at this right here, you could literally put mean for M&Ms and minus mean for Skittles equals to 0, that there's no difference between the bags. And then you could put mean for M&Ms minus mean for Skittles, and then we would put is not equal to 0, meaning that there is a difference between the amount of M&Ms you get on average in the bag. Like, if the alternative, we have evidence for it, we have evidence that there is a difference between the average amount of M&Ms you get versus the average amount of Skittles. Does that make sense? And as you listen to the question, like, let's compare the average amount of M&Ms you get in a bag to the average amount of Skittles you get in a bag. So we're going to see if there's a difference between the true amount of M&Ms versus Skittles you get. We're going to assume there is no difference. The null right here is what we assume. Now, I need to go back to tell you guys some very important wording right here. Julio's kind of, why is the difference? For this one, it's 0, and the question could use other numbers. Like when we test like the average age of UT students, we put 20. That's just whatever we hypothesize as true. So whatever value, if we're seeing if there's a difference, the null would be that there's no difference. So the difference would be equal to 0. If we're seeing that the average age of UT students is 20, that's when we'd put 20 for the hypothesized value. So whatever we guess is true is the null. It's kind of crazy because you can make a null of anything. But here's where we get to the interesting part. Great question, Zach. 100,000 points. Keep those questions coming. So here is where we get to the interesting part about the court case. So Brian recently time traveled and accosted Albert Einstein, or is accused of that. So everyone knows who Albert Einstein is, and I recently time traveled, and I'm getting accused of accosting Albert Einstein. He said I was very rude to him. He's taking me to court over it. He doesn't like it, and he said I'm guilty of it. Now, what is the court going to assume about me to start? The court will assume Brian is what? The court will assume Brian is what? 100,000 points in chat. The court will assume Brian is what? Innocent. Keep those answers coming. I see those answers right there. The court will assume Brian is innocent. That, I know, no way. So imagine this. Imagine you're in the courtroom, and you hear that Brian was in Tennessee the whole time. So there's all these people saying, I saw Brian in Tennessee, and he was there the whole time, and he was just like, totally just Brian there the whole entire time. Dang it. Wait, does he have it? No, wait, is it? Oh, there we go. Is that? I think I have it. Good. I should have used this prop for the last class. So, okay, I got a prop now. It's gonna look horrible on camera probably. So, we have that Brian is innocent, and Brian's been noted to be in Tennessee the whole time. So now tell me, with your null hypothesis, what would you do? So we have here the null hypothesis, and this is just writing it without statistical wording. We have the null hypothesis, and there's a lot of people who attest that Brian is innocent. They say, I saw Brian in Tennessee the whole time. Brian, I saw him, he was eating here. I mean, we're under quarantine, but not in the past. And so, I have no idea there. But we have right here, what are we going to do? What are you going to do to your null? Are you going to reject the null or not reject the null? Brian's been in Tennessee the whole time. There's tons of people attesting to that. Are you going to reject the null? Albert Einstein's been in New York the whole time. So Brian's been in Tennessee the whole time. You're going to reject it? You're going to say I'm guilty? There's so many people saying I've been here. But accept's a bad word. We don't accept it. You just say, I don't reject it. So we don't like to say, and I'm going to throw 100,000 points because you hit the bad accept word. We don't say accept in statistics, fail to reject, 100,000 points right there. That is a great way of saying it too. We are going to fail to reject. But it turns out it was Brian's evil twin during the COVID outbreak. Sorry, I'm not, I'm just like, it won't stick to my face anyways. It was a mustache. So it was Brian's evil twin, Brian that was in New York. But what if they actually saw me in New York the whole time? What if there was all these people saying, no, Brian was in New York. We saw Brian outside of Albert Einstein's house. He apparently lives in New York. So what if there was all these people saying, we saw Brian in New York? What would they do to the null then? What would they do to the null if everyone's like, we saw Brian in New York. He was in New York the whole time. Then they're going to reject it because that would be evidence of my guilt. Does that make sense? I'm not saying I would be guilty, but they'd have more evidence. I mean, what if it was like they saw me outside his house? They saw me trying to break into it. That's horrible. But if they saw all these things, they'd have more and more evidence. So the more evidence you have is for the what? You always try to get evidence for the what. I want to hear it in chat. You always try to get evidence for your what? Do you need evidence for the null or evidence for the alternative? Think about what we just talked about, talking about evidence in this court trial. You look for evidence for the what? Evidence for the alternative, Kaylee right there. Secret, 1,000,000 points for Kaylee right there. So we have it right here. Remember, sometimes first answer will get you a secret 1,000,000. So a lot of times when I don't give points, I'm like, this is good points to the first person. So mega points, 100,000 points to everyone else. So this is the evidence-based one. If there's no evidence in the court, what would we do in the court case? If no one brings any evidence, what would happen in the court case? Brian would still remain what? It's not that they would accept or prove it. Brian would remain what? Watch, do it again. I'm going to do it again. Not sure. Innocent Macy right there gets the secret million. Macy's right. I'd remain innocent. 100,000 points, all those extra answers right there. I'd remain innocent. That's what would happen in the court case if no one brought evidence. They'd be like, well, there's no evidence you're guilty. And I'd be like, okay, I can leave. And they're like, yeah, because there's no evidence. We don't have any evidence you're guilty, so we can't prosecute you. So remember this. The null is what you start out believing. Reject the null, he's innocent. We would fail to reject the null. We would fail to reject the null that I am innocent. We don't have evidence for the alternative. So we would fail to reject, and let's make this super clear. Are you ready? Whenever we do this, here's the easiest way to do it. When we have right here guilty, we'll put guilty down low. So we'll put evidence for guilt. Ugh, so small handwriting. So we have guilty and we have innocent. And then we go here and we would say reject. And then we have evidence. And then over here, when we have over here, the other example we did, we have here innocent, I think that's right. And then we have guilty. And the other thing we could do is we could not reject. And then we have no evidence. It says evidence right there. Sorry for the bad handwriting. So we either reject that I am innocent because we have evidence I am guilty, or we do not reject that I am innocent because we have no evidence I'm guilty. So if there's no evidence I'm guilty, they will not reject that I am innocent. Now, what does it mean to not reject I'm innocent? It just means to, I can't think of it anymore. We either reject or we do not reject. Yeah, we would say that I'm still innocent because I'm not rejecting it. Does that make sense? This is also the same thing as fail to reject. You'll see this sometimes. It's very important you know that this word exists, or this phrase. The phrase fail to reject, which simply means I do not reject. So fail to reject is the same thing as do not reject, because you either reject the null or do not reject the null, and you will either have evidence for the alternative or you do not have evidence for the alternative. So please write this phrase down in the chat or in your notebook. When you reject the null, you have evidence for the alternative. When you do not reject the null, you do not have evidence for the alternative. So you see how it works? When you reject the null, you have evidence for the alternative. When you do not reject the null, you do not have evidence for the alternative. 1,000,000 points first person to write in the chat. Who's got it right here? Keep writing those things. So when you reject the null, you have evidence for the alternative. When you do not reject the null, you do not have. Abby right there. Amazing work. So we got it. So good stuff. Good practice. When you reject the null, you have evidence for the alternative. When you do not reject the null, you do not have evidence for the alternative. Yes. These are huge notes. We should know that when we reject the null, we're saying I have evidence for the alternative. Give yourself that 1,000,000 points if you wrote it. I'm going to slow down the points here in a moment, but keep it up. So here we are with our nulls and our alternatives, and keep those questions coming when you have them. Excellent work in the chat right now. So let's continue on. Here's a big thing. If you notice, there were 3 alternatives. There was the less than, the greater than, and the not equal to. There were 3 alternatives that we could do. With these 3 alternatives, we have to know which one to pick. How do we know which one to pick? How in the world are we going to pick the right alternative here? The answer is we're going to look at the question itself. If you notice when I was asking questions earlier, I was asking things like, do more than 70% of students like Taco Bell? Do more than 20% of students want their steak rare? This would be the greater than alternative. Then I asked things like, are Florida and UT students different ages? This would be the does not equals alternative. It's the does not equals alternative because I didn't say less than or greater than. So if I don't give you a direction for it, it'll be two-sided. And we'll talk more about this in a moment here. Some major important stuff is coming up to make sure you understand what's going on. But there are 3 ways we can go in the direction for the alternative. Less than, greater than, or not equal to. Less than, greater than, or not equal to. So here we see a does not equals alternative. And please note, the only difference between the null and the alternative is what? The only difference between the null and the alternative is what? The only difference between the null and the alternative is what? It's the only difference for 1,000,000 points. Who's got it? Very quick answer here. Sign. Zach got it. So quick, Zach. And you got it. The only difference, 100,000 points for everyone else. So the only difference is the sign. That's something we should just like boom like that. It's like just change the sign. So this one right here could be testing something like, let's see if the proportion of students who like their steak rare is 20%, and let's see if it's not that. So we're going to see if we have evidence it's not that. We see a lot of super important stuff on this screen, but right now we're just going to focus in on this because this could have been greater than or less than. It just depends on the question. We have to look at what the question asks. P-values. I'm so happy. Someone in chat earlier said they learned this in high school and now they understand it better. That made my day really well. So thank you to that person. I was like, yes. The p-value is the probability of our results or results from our stream happening by random chance variation given that the null is true. Does everyone understand it? Can we move on? We good? Okay, no, let's get serious here. What does that mean? What the heck does that mean? Okay, let's look at the previous slide to get a clue about the p-value. A p-value is a probability. Probabilities must be contained between 0 and 1. So all probabilities are between 0 and 1. When we look at this p-value right here, the p-value is going to be the shading on the curve. So I'm trying to highlight it. It's a little hard to see, but it's the shading, the red shading right there, which I've now highlighted. But the p-value is that. I know there's a lot of p-hat on the screen and all this. There's all these things. There's p, there's p-hat, and now this right here is the p-value, like the whole thing itself, not just the one part, but everything right here is the p-value. P-value does not relate, Abby, 100,000 points, you are right. P-value does not relate like directly to proportion. It's not like the p-value and the proportion are the same thing. You do things to get a p-value when you test the proportion. If it's shaded, yep, excellent note right there, Julio, 100,000 points, you got it. So how do we think about this p-value, and what does it mean that's the probability of seeing our results or results from our stream due to random chance given the null is true? What does this mean? Let's take a look at it right here and make sure we understand it. We're going to go back in just a moment here because I want to talk about the p-value specifically for now. The p-value has to be calculated the following way. You have to first go to your result and then calculate things as extreme or more extreme than it. So we landed right here. This is right here where we landed. And then we're going to shade below it. And since this is a two-sided, we're going to shade above it. Now, Julio gave a great note in the chat that if it's two-sided like this, we shade both sides. But if it's less than, how would you shade for less than? What way would you shade for less than? And can anyone compute the p-value for the less than on this slide right now? It says the two-sided p-value is this. What is the less than p-value? To the left. So what is it? 100,000 points, those answers. Who's got a million-point answer right here? Who knows what the less than is? Who knows what the less than is? Any ideas? So think, you can see it on the slide. The answer should be there. What is the less than? There we go. Caleb got it. Caleb, you got it. Caleb got the answer. It is just that right there. Who knows, for another million points, what the greater than would be? So the less than, I like it. I like people are starting to see it now. The less than, I'm going to keep highlighting and showing what's going on right here. Here's our result. So this is our result right here where we landed. The less than is just going to be less than that. No one's got the greater than yet. The greater than would just be, squeak, squeak, greater than that. Who knows the greater than p-value? Any ideas? It's a mathematical thing we've been doing lately. So the greater than, I think you guys are, it's not 0.2, 0.83. No, it's not 0.83. It's Caleb got it. It's 0.933. So think about this. This is a big concept. The less than and the greater than must add up to what? The less than and the greater than must add up to what? Nice job in the chat right there. So the less than and the greater than must add up to what? The less than and the greater than must add up to what? 1, Abby right there. Million points, why not? Great answer. So quick on the answers like there, and I like it. The less than, the greater than must add. Remember, if you're putting your answers right now, you're also getting 100,000. So don't worry if you're like, I can't get those big million. You can still get those 100,000. I give away a lot of them. So stay here in the chat. Keep getting those points. I am going to look at everyone's extra credit and be as nice as I can with the bonus at the end. So keep watching live and keep interacting. So you're right. The less than and the greater than add up to 1. And then look at the two-sided. The two-sided for a million points is always double the what? Or It's always double the smaller. I basically gave away on just, you get points. You get points. So I'm confused with finding the actual numbers. Yeah, I'm going to show that here in a moment. Abby, great question. So this is the note you need on this. Oh, good, Caleb. Nice answer in the chat. So the two-sided is double the smaller one. So if you look right here, this is the two-sided, and here's the one-sided. Does everyone see the p-value here is half of the p-value here? It's just half of the p-value right there. The way we will do this is we will use things like the David M. Lane applet. Does everyone see that this has, I know you guys are like, oh no, the David M. Lane applet. This has 0.2 right here. And you guys are so positive. I love it in the chat. I'm throwing 1,000,000 points for Caleb and Julio asking questions to each other and helping each other out. Keep asking each other questions in the chat and keep answering. If I miss a question, keep asking and answering questions to each other. It's one of my favorite things that people do in chat is help each other out. So we see right here that we would go below. And does that make sense? So this is more decimals right here. I know, right? So we have right here the p-value here. And now we can make the other graphic by going here and making this p-value right here. So does everyone see these are the p-values and everything should be carried out? Please tell me the slides are right with the decimals. Yeah, they just rounded it. So we see that the p-value can be calculated by using the David M. Lane applet. So, yep, and look, this is the less than p-value. And does everyone see how it just doubles it? Does everyone see the doubling? That's the two-tailed. And then we can see the greater than p-value by doing this. This probably helps out understanding it a good bit better right here because you see both of these equal 100% of the curve. Double the smallest one is the two-sided. Does this make a lot more sense to people right here? And I like teaching it a little bit different of way each time. So the small p-value that is one-sided, double it. Yep. Because if you double this, you'll get something greater than 100. So the people that knew the answer had to do it on the David M. Lane. There's a lot of ways to do it. You can do it with calculus, but especially for a lot of our assignments, we'll use the David M. Lane. A lot of people use z-tables. Logan, what question do you have? Feel free to ask. Write anything in the chat. Be like, how'd you find the p-value? Why are we doing this? What's the point? And ask anything you want. So this is a big concept, and I appreciate that. Logan, 1,000,000 points for saying that, because then tell me why you're lost. We got a lot of stuff to cover today. Zach, I'll be doing we'll okay, I think we can do it. You ready? People want it. You got a second vote right there. Okay. Let me pull out my speedrun slides. We haven't done a speedrun in a while, so you know we need it. You'll swing by. I won't be there. Okay, so we're gonna do a semi-speedrun of this. You ready? Let's do this. Let's get this speed run going on right here. So here we are going into our speed run. Oh no, we need no, okay. We're gonna go to the void. We're in the void right now. Let's get a speed run going to save us from the void. Here we go with speed run. Okay, we've gotten out of the void right now. I don't have that thing set up for that. So here we go. We're ready to do a semi-speed run of how do we find p-values and what do they mean. So we need to bring up our timer as per usual. We'll click the timer and we always get this right here. So we're getting the timer up and running. And so here, I'll probably cut the video a little bit differently because it'll be fun. It's like quarantine speed run. So 2 seconds, that timer. I always have to click it twice. I don't know why. I click it twice and then it opens twice. I need to talk to speedrun people about this. Are you going to work timer? Well, we might have to do it without the timer. What fun is it? Oh, it's saying it prevents it from running? Really? Really? Let me go to more info. Run anyways. Okay, cool. I don't know what changed about that. It must have been an update to Microsoft Defender. So sorry about that. I usually comes up with a thing saying something, and well, maybe my speedrun timer is not as working properly anymore. Hey, we got speedrun timer, and of course we get 2 as per usual. No. So there we go, and we got the 1 speedrun timer. We put this off the screen right here. Okay, we're good to go. Okay, let's get this going right here. Sorry, I'm crazy perfectionist about these things sometimes. There we go. Boop. Okay, that's, oh no. 2 seconds. Okay, here we go. We got speedrun good enough to go. Let's do it. So we're going to talk about p-values and how we find p-values. With finding a p-value, we need to start off. This is a big review of everything we're about to do today. So, I don't believe that. Wait, Zach, you made me lose my concentration. We got you scared me with that, Zach, there. Are you ready, Zach? Here we go. You and your jokes, Zach. So here we go. Here is a speed run of everything we're about to do today. Is everyone ready? Listen in. Here comes the speed run of everything you'll be learning today. So when we do statistical tests, the first thing we need to do is we need to write a null and an alternative. So let's start by just making up a question right here. Let's see if the proportion of students who like Taco Bell is 70%. So we're going to start off right here by writing HO for the null hypothesis, and then we have to write what we're testing, which is the true proportion is equal to 70%. Then we go and write the alternative, HA, and this is going to only change the sign. And in my question, I never said anything about more than or less than. This is only not equals to because I never gave you a sign to the question. This is the first step you do when you do any statistical test. So I can't say how important it is. I know I'm wasting time on my speed run, but you have to know how to write the null and alternative. You have to know that the only thing that's going to change right here is the sign between them. You have to know the first thing is the population parameter you're testing, and the third thing is the hypothesized value that the question asks. Like, is it that 70% of UT students like Taco Bell? And since I didn't give a sign for it, like less than or greater than, we just do does not equals to for it. So that is how we write the first thing we do, the first step of doing a test. The next step in doing a test is to choose the right equation. Now, this is a one proportion z-test. That's also the same on your TI calculator, one prop z-test. So we need to know the equation for it, which will be given to you on the test. We have here p hat minus p naught over p naught q naught n square root. Now, if you hear that, p naught q naught over n square root, that's a big thing. The only difference is the sign right there. So if you write the null, once you write the null, you can just write the sign for the alternative. That's the only change right there, as the only change. What's the naught? That just means the null right there. The null right there, that just means the naught. It's like H null, it means the null hypothesis. And so what is this null right here? This null right here, secret, 10 million points. What is this value right here? In this notation, what is it? Secret 10 million points. What is that value in this question? Zach, oh my gosh, Zach, you just destroyed it. Zach got ridiculous points. This is the hypothesized value. So there we go. Zach got it. Zach got the secret 10 million. I wanted you guys to be listening in and following along, and you did it because right here, this is also P naught right here. So you may not know that already, but this is the value we are testing. And so let's go back in time right here, and you'll see that we have here 0.7, and that is P naught. Now, p hat, we need to know from our notation, is what we see in Sam. Remember, Zach's the only one who got it, but everyone else gets 100,000, and we will get the formula sheet. And you won't have to solve like for the p-value because that requires calculus. But you will on your homeworks, not on the test though, because that requires calculus. So we see right here that this formula right here is just a difference standardized, and it'll solve for a z-score. So this right here is just going to solve for a z-score, which is just the difference between these values, what we observe in our sample, versus what we hypothesized is true. Then we do this right here, which standardize it. P naught is 0.7, so Q naught is 0.3. They just add up to 1. And then N right here is the sample size, so we'd need that in our problem. So now in our problem, we might say something like we spoke to 200 UT students, and from those 200 UT students, 160 of them like Taco Bell. So we can see right here that this would be P hat equals 160 over 200, and P hat equals 0.80. So P hat equals 0.80, and we can start plugging things into our equation. So we're completing step 2 right now. We'll have some conditions we'll check here in a little bit, but we're just going to put into here 0.80 and 0.70. Then this is P naught. Remember, it's not P hat. And then this is 200 right here. And we solve this equation. This is just going to give us z, so let's get our calculator on the screen right here. And that's 0.7 times 0.3 divided by 200, and then we square root it, and then we take 0.10 and divide it by that. That's the top part, and we get a z-score about 3. Now, this is another secret 10 million. I want someone to give me a guess of what the p-value is. You have to be very close. Who has a guess of what the p-value would be? Who has a guess of what the p-value would be? This one is one you can kind of get close. Secret 10 million. I need to calm down the extra credit points. But I think this is a very tough but good question. We know here. I'll show you what it looks like. This is the third step right now. People are getting close. I see some very close answers, but maybe check your answers. I think some people are getting very close and they know where I'm going with this because I didn't intend for this, but it happened. So I think it was 3.09 and 3.09 rounded. No one's got the right answer yet. So that's the z-score. So, but remember, this is a z-score, and then let's think about how the graphic's going to look. This is now the third step. This is step number 3. So this was, let's put it up here. This was step 1, this is step 2, and step 3 is going to be to draw the distribution, which we can do on David M. Lane, but I want to see if anyone can get it. I'm going to start drawing it. We'll see who gets it first. 10 million points on the line right here, ridiculous points. So let's go here. Tell people Brian's giving away ridiculous points. Come to class. So we need to draw like we were doing in the notes. And let's go here. Very close to the right answers. I need more exact, and I need to know how you thought it up. So people are getting closer, but no one's gotten it yet. I think I might take that answer. I think we're going to give it to Catherine. Because Catherine's going to be really... She might have looked it up. So I want us to look at what we have right here. What percent of area on the z-scores are located within inside of here? Within -3 and +3, what percent of area is located inside the z-scores? Within -3 and +3, 99.7, you're right. So what percent of area would be outside of here? Remember, I'm doing it as a two-tailed because of this sign. It's two-sided because of this. So point and then on both sides. So make sure you do both sides and there. Anne gets the answer that I was looking for right there. So remember 0.003. Remember, so I saw some stuff earlier and I was like, the decimal seems to be off by a tiny bit. So that's why I was like, it looks close. And I see where you're going with that. So right here on the outside would be, if we go here and kind of do an outside thing, the outside areas on these is about 0.003, and that's very close to the p-value. So we're going to do the David M. Lane here, applet, and check it. We're going to have to resize the screen a little bit for it. So here we'll bring it down over to here, and we'll change the screen size up a little bit. But now we got the David M. Lane in here. Good job. So what we'll do is we're going to go to z-scores right here, a mean of 0 and a standard deviation of 1. Mean of 0 and a standard deviation of 1. And then we go here to outside of -3.09 and 3.09. So if you notice, you can barely even see it. Do you see how that's that tiny, if you don't believe me, that is a tiny bit of area. I can change it by going here to like -6, and now you shouldn't see it. You see it's so hard to see, but there's not shading in there now. And if you watch it, you can see the shading over there. It's so tiny. The answer is not -0.06, but I was just trying to show that the area was being shaded. You'll see it appear now. It's so small. And if you look, Catherine was totally right. We were kind of estimating it, but look how close our estimate of 0.003 was. We estimated about 0.003. The p-value is low. We reject the null. Perfect answer right there, and that's the last step. And so, and Kaylee, million points for helping out right there. Looked like there was a question. Thank you so much. Yeah, and Snay, you got your question answered, million points. I really mean it. I really appreciate you guys. When I miss a question, I appreciate people answering it. And that's why we reject right there. So we'll hop back here to our Word document. And the final step, step number 4, after we do all this, is simply to reject the null or not reject. So tell me, is my p-value low? Is my p-value low? I reject. And we had the null. And we'll put I have evidence. Let me do I had it so perfectly. Oh, good. I reject. I have evidence for. And we're answering. The null was that the true proportion is equal to 70%. Okay. And the alternative was the true proportion is not equal to 70%. Okay. This is the final part. So since the p-value is low, we reject the null. Yes, Abby keeps saying that when the p-value is low, we reject the null. When the p-value is high, just let it fly. When the p-value is low, reject the null. When the p-value is high, just let it fly. So we see right here, and I think we got it done. Oh, no! We're going to go sub 10. I clicked it too quick. But this is everything right here, a full test problem done with all of the solves on it. The biggest thing to know right here is when you get to the fourth part, you will either say I reject the null, or you will say I do not reject the null. You will either say I have evidence or I do not have evidence. When the p-value is low, reject the null. When the p-value is high, just let it fly. You're exactly right. Nice job, Zach. So what we say right here, please say it as a sentence. Watch as I say this. Practice along with me. Million points if you put in the chat. You got to write the full thing, though. I reject the null hypothesis that the true proportion of students who like Taco Bell is equal to 70%. I have evidence that for the alternative that the true proportion of students who like Taco Bell is not equal to 70%. Please take a look at what I've done. I've just taken my null and alternative from up above and said I reject that, or I have evidence for that. So which one is the evidence one? It's always the alternative. Which one is the one we reject or do not reject? It's always the null. So remember, the null always has I reject the null or I do not reject the null. The alternative has I have evidence or I do not have evidence. It's the best way to keep it in your head. Be like, okay, now when I do this, I need to go back and look at my null that I wrote and be like, okay, I reject this. And when you read it, I reject the null hypothesis that the true proportion of students who like Taco Bell is equal to 70%. I have evidence for the alternative that the true proportion of students who like Taco Bell is not equal to 70%. This is so key right here that you realize all of this comes down to writing the null and writing the alternative. How low does it need to be? Less than 0.05. We'll see that in the notes here in a half second. Let's hop back to the notes right here. I'm going to start setting up more where I think it's just going to do the regular transition now. Let's hop back to the notes. All the stuff on the screen. There we go. And we'll close the speed run down. I hope, did that help people out right there? Come on, mouse. Do it. Right there. Okay. I hope that helped out a good bit. It was kind of a quick example, working through a problem. That's how your homework problems will be. So I think that's probably going to be pretty helpful right there. And it really covers everything we're covering today. Like what you saw in that 10 minutes is what we're doing step by step by step. And nice answers in the chat. So we see here that we can do one-sided or two-sided alternatives. And the reason I shaded the way I did on mine was because it was a two-sided alternative. Remember, what would the p-value be for the one-sided alternative? Who can tell me right now the p-value for the one-sided alternative? Think, if it's this for the two-sided, what would it be for the one-sided? What would the p-value be? How did you say the p-value has to be? Below 0.05, Kelsey. 100,000 points, Kelsey. Below 0.05. Dylan, you are right. 100,000 points. Dylan right there. You're right. It's 0.00001. Now, what would be the greater than p-value? What would be the greater than p-value? If we did a greater than test, what would be the greater than p-value? Great answers in the chat. You understand that the two-sided is double the smaller one. And then, is it going to be exactly that? It's 0.99. So, great job and great questions in the chat. Keep those questions coming. I really appreciate you guys being here asking questions. And you see how the two, if it's like 0.001, then this one is 0.99. So very important. If the p-value is below 0.05, we reject the null. Correct. And technically 0.05 is what is assumed to be alpha. And we'll see that here as we go through the notes. So I think, and I skipped some, we're checking out. Here we go. So this is exactly what we were talking about. Great notes that you're taking right there. Is that 0.05 is what we assume to be alpha. So alpha is when you reject the null. You'll see this in later lectures, that alpha is assumed to be 0.05. So 0.05 is what we call statistical significance. So if the p-value is 0.03, do we reject the null, yes or no? I want to see in the chat, everyone, for 100,000 points. If the p-value is 0.03, do we reject the null? If the p-value is 0.03, yes, get that 100,000 points. Yes, we reject the null. And is the p-value of 0.03 statistically significant? Is the p-value of 0.03 statistically significant? The answer is most definitely yes. The p-value of 0.03 is statistically significant. The p-value of 0.03 is statistically significant. So great job. It is significant. We do reject the null. Absolutely statistically significant. Now I'm going to teach you an advanced thing because you can change alpha. what if alpha is this, which is a harder p-value to get? Would you reject the p-value here if we change what alpha is? Now, alpha is assumed to be 0.05 unless we specify it. Would 0.03 be statistically significant? And Zach gets it. It's not, because the p-value needs to be less than alpha. So we can change what alpha is. We do that in some questions. But unless we state otherwise, alpha is 0.05. And 0.05 is what's generally regarded in the world as statistical significance. And it would not be, in this new example down here, it would not be statistically significant. But what if we change alpha to something like, we've done this just as ridiculous test questions, is this now statistically significant, yes or no? The way you know is you look at the p-value and you ask, is my p-value less than alpha? And since the p-value is less than alpha, this is statistically significant again. So the steps to know if something is statistically significant is p-value less than alpha. Alpha is assumed to be 0.05 unless stated elsewise. So remember, when your p-value is low, reject that null. When the p-value is high, just let it fly. That's what we keep saying right here. When the p-value is low, reject the null. When the p-value is high, just let it fly. We get into the last bit of the lecture, which is exactly what we did in the speed run. So let's review. Who can tell me for 1,000,000 points the first step when you do your statistical test is to do what? And it's very important you do this properly. The first step when you do statistical testing is to do what? And if you don't do this, the whole problem goes crazy. You have to write your what? Identify the null, you're right, create those hypotheses. You got 1,000,000 points all the way up to do Abby right there. Think up to Julio and everyone. Why not everyone doing it right now gets 1,000,000? I said the points would be crazy today. Keep coming to class because these points matter. They matter towards your grade. Put them into the sheet. Remember to write them down. So we have here the nulls and alternatives we can write. The first thing we do is we write down the null and the alternative, and we get this right here. Boom, we got our null alternative written. The second thing we do is we identify what test we're going to use. Now, there are some assumptions. We'll talk more about these assumptions next class. I bet you can't guess. Condition 1, random. Condition 2, 10%. Condition 3, it's proportions, so it's success failure. So you always have to think about what tests am I doing, and we have to do the conditions for them. So we've learned these a lot. Random button, you got it. You know it's random button time. We have not clicked that button today. I gotta do it more randomly though. My Stream Deck has a problem, so we'll get that fixed. Okay, so let's take a look right here. This test was what I wrote out earlier. Know all your notation. All your notation is in the null hypothesis, it's just null, is that the true proportion is equal to some hypothesized proportion value, just whatever you hypothesize it to be. The z-score is the standardized difference between the sample proportion and the true proportion, the hypothesized true proportion, that's what we hypothesize to be true, over the standard deviation of the sample proportion, which is P0 times Q0 over N. Now, if you'll notice, what's weird about this is we're not using P and Q. We don't know P and Q. We are assuming that P0 is equal to P. I'll try to create that this weekend, Abby. It'd be really cool with this. I need it to cover the whole screen. I need it. Abby, we need that. Thanks for reminding me. Sorry, with this crazy semester. Jason and I have like a list of things we want to create, and then time gets away. But Abby, I want it to. So we have here the mechanics of it. This last part is there's one part of this, is finding the p-value. So when we find the p-value here, you saw me do this. Remember, these steps you're reading right now were the steps I did right here. Step 3 was to find the p-value. So step 4 is to state your conclusion. The final fourth step on this is to simply reject or do not reject. Now, don't say that bad accept word. Don't say you accept the null. Bad stuff will happen. It's a bad thing to do. And I think that does it for this whole thing on doing hypothesis testing. Would you guys like if we did a problem from this chapter? Who wants to do, we could do another problem if you want. I've got videos on, can you go through the steps again? Yeah, how about we do a problem from this chapter and we'll go over the steps. Because I didn't put this in the earlier video. So I always like doing new questions with everybody, like as many different types of questions as I can do. Halo Reach is calling you. That's awesome. Yes, problem, please. Okay, let's do a problem from this. Okay, so here we go. Conference rules what mean. Okay. I don't know if I have Halo Reach anymore. Maybe I have it from like the Master Chief collection. I don't know. Okay. Here we go. Let's just write the null alternative. We got this. The null always has the what sign. The null always has the what. And then we'll do chapter 14, part 2 next. We'll do that, Neely. So we'll hang out here a little bit longer and we'll do chapter 14, part 2. You got that, Neely? Because I know you asked that. Null has the equal sign. Boom, we got this. And then they want to see if they can keep their positives above this. So if they want to keep their positives above this, then we would do the what sign here. If they want to keep their positives above this, it'd be the what sign. Which alternative would it be? I think you guys know. I'll do it. Check answer. We got it. So, and then this is proportion of dice rolls. We'll continue on here. I want to do kind of one full problem this, and we're going to do Neely's problem here. P-value, it's the probability of the raw results from a stream occurring due to random chance given null is true. And then here we go. Okay. So then we got Neely's problem next here. So stay tuned, Neely, and then we'll do 14 part 2 I think you wanted. So we have right here that we need to write the null and alternative. We should try to write this without the problem telling us. It's good practice. We have here that in 1997, numbers are often used as baseball to assess changes. Julio can tell us if that's true or not. In 1990s, oh wait, oh baseline. I can't read. In 1997, 31% of students had not been absent from school. And in 2001, see, it says 31% is going to be used as a baseline. So since I know 31% is the baseline, we go right here and we go the null, not with highlighter. So we go, I can't read. It's a problem. We write the null hypothesis, and I can't use my black pen today. We write right here that the null hypothesis is that the true proportion is equal to 0.31, and the alternative would be that the true proportion, I think it's going to be they'll note any change in it. I'll show that off in the problem, but the problem I think states, because I've done this problem, I swear, they're going to, oh wait, officials would be concerned if the attendance would be declining. Oh wait, did they totally change this problem this semester? Officials would, of course, be concerned if students' attendance is declining. Here it is. Yeah, they didn't change it. That's what really gets people. What gets people on this problem, and I'm glad I'm doing it because this one tricks a lot of people, is it says, do these figures give evidence of a change? So if we're doing evidence of a change, evidence is always for the what? Alternative. Like this keyword right here, it's such a good test question now because it literally says evidence for a change. It's going to be not equal. So we go to equal and we go to not equal, and it's good to practice. If you notice, I went to my notebook and I wrote this down to make sure I did it right, and I got the same answers. So we should get it right. We did. The conditions are random, which is also independent, is plausible, 10%, sounds like it's less than 10% of all students, and success failure. For success failure on this one, we have to use P naught times the sample size. The sample size here is 8872. So we take and we go to 0.31 times 8872, and there's NP naught, and NQ naught's only larger because NQ naught will be 0.69 times 8872. Remember, P naught and Q naught add up to 1, and these are really large numbers, so this is definitely met. It's not that it's plausible, it is met. We just did the mathematics on it. We got all those right. Find the z-score. Now remember, for the z-score, we have to go over here, and we have to look at our equation. There's the equation, but it's all filled out, so we need to do that ourselves. It was 8872, right? So we need to write here our notation. N equals 8872. P hat equals 30%. That's what they saw in the sample. P naught equals 0.31. Q naught equals 0.69. And I think that's it. If I'm thinking the equation correctly, because now we need Z. So Z equals P hat minus P naught over P naught Q naught over N square root. So we just need to solve this right here with the notation we have, and we should be pretty good on this problem. So let's go here and do P hat, I messed it up, minus, there we go right there. That's the top part of the equation, as long as I'm not flipping the numbers. And then we go here to the bottom, P naught times Q naught over N. Hope that's the right number. And then we square root this. There we go right there. And the top part of the equation was negative this. I'm just going to do that. And there's the z-score. But the good thing is, so it's a negative z-score technically, but the good thing about this is since we know the z-score and it's a two-sided test, remember on the two-sided, we shade the outside as we've been doing throughout class today. And think about this. it's basically outside of 2, so it's going to be a little bit less than 5%. And, well, I could just double that number and know the answer now, but it's a little bit less than 5% right here. So because outside of 2 is 5%, so it's a little bit less. Do section 2 quiz graded averages include? Yes, chapter 13 is part of section 2. Chapter 13 is part of section 2. And so, well, that's not the z-score. We need the z-score. Let's go back. We got the p-value. So we go here, it was negative 2.06. Negative 2.06. Did we get it right? Oh my gosh, what went wrong here? Did I take the wrong numbers? 8872 and 70%. Let's check the math. Okay. Let me stay on this screen and look at the math because it looks like I might have taken the wrong number. 0.7 P naught, because P naught is, oh my gosh. P naught is, I did the bottom wrong. Don't go too quickly. That's a common mistake. Let me rewrite it then there on the bottom. It's going to be so close to this. And square root. And the figure had gone down. So it's 2.04. Wow, because I took the wrong one. And so now I'm going to guess the... There we go. I'm going to correct my error. I wrote all my notation properly. And then I was just going quickly. And my error was, it's so easy to make an error on this. I was even saying in the last class, you can review the tape. I was like, a lot of people make this error. So remember, a lot of people make this error right here that they put p hat down here. I was just trying to keep the numbers in my head as I did it. And that's a bad idea. Write down your work as you do it. I subtracted correctly on top, and then I put p hat in the bottom instead of p naught. So the only issue I had... oh no, it was that I put, or maybe I did that. I hope it was that. Maybe I did. Yeah, I'm wondering. I'll review the tape. Kaylee, did I do that? If you rewind time, it'd be interesting if I did that, because maybe I did it properly and then I think I put 0.7 because I was just trying to subtract and do things in my head. But remember that this is Q naught. We already put all our notation here. Plug your notation in proper. Plug it in correctly. Kaylee, million points. Thank you for watching. That might have been my error, but now we have it correctly solved and we have the correct answer. So easy to make a small error on this. We know that our p-value should be a little bit less than 5%. Just kind of guessing. So now I'm going to guess this one. See, there we go. We got it. And if you remember, I'm just going to change the David M. Lane so it shows it. It's just going to be, you put this, and there's the answer. And I got it via rounding. Yep, the drop will be in the averages. Yep, the drop will be included. So we will include that drop so you get the benefit of that. Using an alpha of 0.1, would you reject the null? So we would reject the null. There is evidence to conclude that the attendance has changed. There we go. That's got it. And do you think this difference is meaningful? It's probably not meaningful because the observation change is quite small. So it does not have to... Yeah, the difference is probably meaningful, is not meaningful. Okay, there we go. That should be right. Cool. Okay, 14 part 2, 14.2. Wow, that was like a lot of points to that quiz. Let's hop here and do 14 part 2. So Neely, was there one specific you wanted me to do? Oh no, is my Pearson going crazy again? I hope Sophie is not going crazy. It seems every night after about 5 p.m. it starts to get really rocky on my Pearson. So if it is having problems again tonight, we'll open it again. We're trying to have one full day because it worked all last week. Specifically questions 2 and 3. Is it the quiz or the homework, Neely? The quiz or the homework? The homework is always static. The quiz changes. So you might have to tell me like which question it is. Let me get 14.2 homework open because if it's the homework, it's the same question every time. But the quiz will change. The quiz has a lot more questions on it. So homework. Oh, perfect. Then it's going to be 2 and 3. Let's do 2 and 3. As long as I can do them well in class with that. Okay. Is this it right here? Is this the one right here, Neely? The bank problem? Nutrition lab and about flights. Am I doing 14.1? Is it the I think it's conference rules. I think I chose the wrong one. Because I can't read. Yeah, I think it's conference rules. So let me do that. So that's part 1. Yeah. That's what I thought. It's the screen is still far away and everyone knows I'm blind. So Brian is very, very blind. It's like this large text is big. I'm kidding. I can read that. So let's go right here. Nutrition laboratory, we got it. Here we go with the nutrition laboratory. So in nutrition laboratory, test 40 hot dogs right here. Let's do this. Thank you, Neely, for staying. And I'm always trying to put as many of these I can into videos because I know people will watch them and try to learn from them. And I appreciate that. I know a lot of people work very, very hard, and having a video can help. Like some people might just try to skim for answers, but other people are like, okay, how does this work? How do I do the notation? Okay, so let's do this. We got 40 hot dogs. 40 hot dogs is N. That is our sample size. We have identified sample size. We've got the mean sodium content right here. The mean sodium content from the 40 hot dogs is Y bar. That's because it came from a sample. Last but not least, we have the standard deviation, and that's the standard deviation from a sample. So that makes that S. So right there. Oh, you're welcome, Neil. I'm so glad that helps you guys out. So we're almost there. We've almost got this problem. We just see one more part of it where it wants a 95% confidence interval. And so when we do a 95% confidence interval, we're actually going to need to find T. So the 95% confidence interval is where you have to find T, and we need to use this in the equation. Actually, there's one more thing, Neely. Do you know what else we can find from N? I'll say it since it's getting late and I want to make sure I can answer all the emails and everything. We've got here the degrees of freedom. So the degrees of freedom equals 39. Now, someone said in the last class, T's get degrees. And we remember that the T distribution has with it degrees of freedom. So T's get degrees. So we need to actually go, and I'm going to pull up an applet right here. This is my favorite one for this. It's stat distribution's T distribution. And it's my favorite one to get the answer from because I like the way it views it. So we have here 39 degrees of freedom, 95% confidence interval. And statisticians are like, you could have used that. I'm like, I know, but I like this way this looks. So we go here, and that tells us the T-score for a 95% confidence interval with 39 degrees of freedom. Every time you do T-statistics, you have to know the degrees of freedom. I can't state that enough. When you do T-statistics, you have to know the degrees of freedom. That's so important. When you do T-statistics, you have to know the degrees of freedom. So we now know the T-statistic used to create the confidence interval is 2.023. So let's hop back over here to our notation, and the T for this is 2.023. That is the T for a confidence interval with 39 degrees of freedom and 95% confidence. Notice how we have here 95% confidence and 39 degrees of freedom. That is the information we need when we put it into this applet. 95% confidence, 39 degrees of freedom, as you see the things that I am removing the circles from right now. So we now can write our equation, and the equation is y bar 1 plus or minus, or y bar, excuse me, t n minus 1 degrees of freedom, s over square root of n. This is the equation we will use to solve for it. This will be given to you on the test, so no worries on that. We just need to know that this is an interval being made from the sample mean to estimate the true mean right here. So right now, the problem is pretty much just plug in the numbers. So I might go to the other problem here, but from here, we just put in y bar, which is 320. Then we go plus or minus, and we put in the t of 2.023. We do the standard deviation of 37 divided by the square root of 40. Let's see if we can solve it in our heads. Square root of 40 is about 6 point something pretty small. 37 divided by that is also about 6 times 2 is 12. So it should be about 308 to 332. 308 to 332. Of this problem too, yeah, let's see. Let's see how I did my guessing at it. So I'm guessing how it works. I'm just kind of doing it in my head. I love solving problems that way. It's a good, fun way to guess it. So I'm going to say 308 to 332. We got it. Did it in our heads. That's the way we do it. So once again, all of this is just solving out the problem with the mathematics right here. Just solve the mathematics and see if you get it. That's my redemption for getting something wrong earlier, for mixing something up. So it's fun when you get it. It's like a game. That's what we do. So what assumptions have you made? Condition 1 for this is random. Condition 2 for this is 10%. Random, the hot dogs were randomly selected, which also means they're independent of each other. So we have here that the hot dog weights are independent. The distribution is nearly normal. That's our large enough n / nearly normal condition. And we have it. That looks to be good. Final check. We're good. Final checks scare me. Is the randomization condition satisfied? Oh my gosh, this one. This one. It never really says. We don't know, but it is reasonable. Sure. Good. So that's that one right there. We don't really know. Yeah, 40 hot dogs is less than 10% of all hot dogs in the world. So yes, 40 hot dogs is less than 10% of all hot dogs. There's a few My Pearson ones that are tricky on these where they switch up. They'll be like, it's safe to assume or it's not safe to assume. But so I always hate those, like, assume this, because I'm like, really? This right here, we don't know the shape of it, so that's a bit of a problem. To do the nearly normal condition, we'd have to know the shape of it. It doesn't say anything about approximately normal on it, does it? It doesn't, so we can't say yes or no. But it's a pretty decent sample size. Yeah. 40 is decently large. Small samples are like 10 or 12. Explain clearly what the interval means. I am 95% confident the true... Look, I'm not looking at it. I can actually see it over too. I'm 95% confident that the true mean weight of hot dogs is the true mean sodium content of hot dogs is contained in the interval blank to blank. Thank you for the sub right there. Thank you. We got a few subs today. So I'm 95% confident that the true mean weight of hot dogs... Oh my gosh. I am 95% confident that the true mean sodium content of hot dogs is contained in the interval blank to blank. So it's these types of hot dogs. So there we go. Remember to do your interpretation. I am blank % confident that the true blank is contained in the interval blank to blank. And that's got it. Does that make sense there, Neely? How'd you do on that problem, Neely? Pretty good? Pretty good on the problem? We might have gotten monetized because we had I'm interested to see if our channel got monetized because we had people randomly join the stream. Awesome. You want to do this one real quick, Neely? We'll solve this problem, then I'll probably head off. We had people randomly join the stream. Julio, great job on the answer right there. I just saw your answer. I guess that's the exact answer. I was close enough. My Pearson was like, you got it. You got it. Okay, let's do this one from here. Check the assumptions and conditions for the inferences. We have here that we are going to delayed arrivals. So could these be considered a representative sample? There's no evidence of a time trend, so it's not time series data. The correlation is this, that's the R. So check the assumptions and conditions below. All the assumptions and conditions about the mean are met. I think so. I don't see why 10% would not be met. The randomization condition is not met. No, it's independent, it's random. And that is going to pass the nearly normal. Like this is a pretty large, what's the sample size on it? 72. This is a pretty large, I'll give advice. So I'll give that real quick to Zach right here. Definitely, I think the Kahoot's really good. I'm trying to be as fair as I can with my advice. Like I'm not trying to give anyone like Brian gave out super advice at the last moment, but just review each question, use your formula sheet as best you can, like look at it conceptually. So definitely use the formula sheet every bit you can, like to see like how do I solve this or what does this mean for confidence intervals or this. Check answer, good. All conditions are met. Condition 1, random. Condition 2, 10%. Condition 3, nearly normal. 95% confidence interval. Okay. So here we go. You're welcome, Zach. So here we go, Neely. What is an additional thing on this screen right now that you do not have notation for that you can find? So Neely, what is an additional thing on this screen right now? Look at all the notation in the blue box. What's an additional thing that we can get notation for that we do not have right now? What is an additional thing we can get notation for? We have N, we have Y bar, we have S. What's an additional thing we can get notation for since we're doing a T interval? Kyra, thank you so much. Maybe we're getting, I don't know. It's the first time I've seen all these subs. Thank you, everyone who's subbing. So subbing and like the videos, that really helps the channel. Degrees of freedom, Neely, you are right. You got it. So what are the degrees of freedom? It's n-1 for a one sample T. So we've got here, it's 71 degrees of freedom. And they said make a 99% confidence interval. So in here, I'll send you this in the chat here. This is my favorite applet to use. You can actually send someone the link for it. It's really just a nice looking applet and just like the way it works. So the t-score is 2.647, and this problem is now very similar to the last problem where we're just going to change the t really. So this is 2.647. I think it was that. So 2.647. Yep, there we go, 2.647. And then we had the sample size of 71, and I don't know the other values. Let me look at those other values. So we need, if you notice, Y bar and we need S. So Y bar is 2.3889. So 23.889. I was having fun memorizing. I was like, no. 23 point. Why so many decimals? Why? And then this was, how close can I get to it? 2.72325. If I had more confidence, I would just use it. 72325. Let's see if that's right. 72825. Dang it. That 3 looked like an 8 when I looked at it in my head. So, bummer. No, it was a 2 there. That 3 is just in my head for some reason. So, better memory when I was younger. So, here we go right here. This looks to be right unless I've miscopied a number. Let's hope I haven't. We're just kind of working quickly if I make mistakes because miscopy probably. So, we have right here, we need to do square root of 71. Wait a minute, was that the degrees of freedom? That was the degrees of freedom. Brian, slow down. The sample size is 72. There we go. This is what I get. I get one question right, and I'm like, I can do them all now. So here we go, 72. It's the end of class if people didn't know, and I'm dropping my pen. So 72, square root. We take 2.72825. I should have done this one in my head too. Why not? Let's go for the, it's the end of class. Let's go for the double win right here. We gotta get the 2 problems solved in our head. 72 when you square root it is between 8 and 9. So it's gonna be about 8.4 or so. Let me think about how that works. No, it's gonna be like 8.6. 2.7 times 8.6 is going to be 16, and then a 7th of 8. So it's going to be like 20. That's going to be, it's too many decimals. It's going to be like plus or minus 50. The margin of error I'm estimating to be about 50. We'll see how close I was on the margin of error. So I'm thinking a margin of error about 50, and then we're going to times this. I think we got this right here. Divide this by this. So there we goes that. Times, no wait, 2.7. This is when Brian's been online too long. Oh, wow, I didn't carry my decimals. Okay, I would have been way off because I was not doing decimals properly. Got one question right and thought I could get them all right. So there we go, is the margin of error. So that's the margin of error right there, Neely. We just solved for the margin of error. And 23.889, I should have noticed that something was off on the decimals on this when I got such an interesting number. Plus or minus. And then we go here, 0.8511. There we go right there, and that should be the answer, but it's a fun one to deal with. So we go 23, we'll go back to our screen right here, 23.889. Let's hope we carried the numbers correctly. 23.889 plus margin of error, so 24.74. I was waiting, Julio. I was hoping you'd be like, you'd get the answer too, and we could confirm the answer. And then we go here, 23.889, right? Minus the margin of error, 23.04. Woo! Don't know why I was scared. I was just flipping numbers. So I am 99% confident that the true flight time of such and such. So here it is. The delayed flights. So we are 99% confident that the interval contains the true proportion of delayed flights for the months. There we go right there. Always make sure I am blank percent confident. That's got it, Neely. How's that look? Been on the line a while, so I'm like, it's time to end class. But I appreciate everyone so much. Did that help out a good bit, Neely? Does it make sense on how to use this equation right here, that you always have to get the t and you have to get the degrees of freedom with it? The thing that really gets people stuck is using this applet a lot. I often see where people get stuck on that because they're like, wait, how do you know the degrees of freedom? How do you know the number to put in there? But you do it based on the percent confidence. Yep, so much better. Yes, Neely, that's awesome. Glad to hear that. And always feel free to say I have another question. Like if someone said they had a question now, we'd do it. We'd get that question done. But you're welcome, Neely. Does it make more sense? Dylan, good to see you, Dylan. Making more sense. So the applet, I'm guessing, is making more sense right now. Keep asking questions, and I'll keep staying after class like I do right now to help people. And I'm going to start putting out a schedule. It's just been so crazy. Everyone knows that. Whole world's crazy right now. But I think this does it. I think people understand how to do this now. And I'm going to head off. So I will see everybody later here. Talk to you guys later.